All of our sponsors, all of our sponsors are vital players in the movement to green our homes. These are my essential partners on this event. I want to start by just calling out Kathy Kramer of Bringing Back the Natives Garden Tour. She had the idea to create the Green Home Tour in the first place, to follow the Natives Tour. And I really hope that some of you are returning that got to see her and Mike's great remodel and garden last Sunday. The Berkeley Electrification Working Group, which I co-chair, motivated me to create this event with Kathy Kramer's guidance and encouragement. We have working group members featuring their homes today and members active in the chat ready to answer your questions. Helping with production today are Rebecca Milliken of the City of Berkeley's Office of Energy and Sustainable Development and the Ecology Center's Program Manager of Education and Engagement, Peng Lor. Big thanks to the City of Berkeley and Ecology Center for their terrific support and expertise. I also want to acknowledge my teenage son, Jude, who handled all the videography, drone shots, and video editing. This event is a labor of love and it was produced on a shoestring budget. And if you find it useful or inspiring, I really want to encourage you to donate at eastbaygreenhome.com/donate. Also, because video takes up a lot of bandwidth, depending on the speed of your internet connection and the strength of your Wi-Fi, your viewing experience may vary widely. But I want you to know that we're going to be recording this event and making recordings available later so that if your bandwidth isn't working out for you today, you'll still have an opportunity to watch the program at a later date. So now I'm going to give it over to Peng, who's going to kick us off today with a quick Zoom primer for those of you who are new to Zoom or just need a little refresher.
Hi and good morning, everyone. Thanks for joining us, and thanks, Amy, for the introduction. So I assume that many of you have experienced Zoom meetings throughout this past year. And just in case you are new to Zoom webinar, which we are on, or need a refresher, I want to share with you features that will be most useful for you today. So at the bottom of your screen, you will see 4 icons, which are also on screen, and that is chat, raise hand, Q&A, and live transcript, which is the box with the CC. And so chat is for making comments and engaging with other attendees. So please note that you have the option to chat with panelists and then chat with attendees. So chatting with attendees will allow everyone to see what you share in the chat box. And we will also, as Amy shared too, have chat ambassadors that will engage and drop useful links as well. So every once in a while, we may ask you also to show your hands or show of hands. And so right now, let's give that a test. So raise your hand if you attended last Sunday's Green Home Tour. So you click on the hand to raise it, and then great, wonderful. Thanks for participating, you all. And thanks for joining us again. Great, and so that's how it works. And then you can click raise hand again to actually lower it. And then Q&A is for questions only, and specifically questions that you want to ask speakers, homeowners, and presenters about the topic at hand. And then the live transcript icon will allow you to disable or enable the live transcript on your screen. So here are several ways to ask questions of the speakers. So after each of our 10-minute home videos, we do a live Q&A with the homeowners. We will select a few questions from the Q&A fields to ask them. And please note that asking questions in the Q&A icon is also preferred, so your questions don't get lost in the chat box. So please distinguish those differences, the chat box and then the Q&A. And at the end of today's program, we'll have an extended Q&A with energy experts, homeowners, and architects. And during that last segment, you can again drop your questions in the Q&A fields. And lastly, we will regularly drop a link in the chat to a Google form for pointed questions. So after the green home tour, we'll take the questions you put in the Google form and forward it to our experts and homeowners to answer. And you may hear from them a few weeks after the event. And I want to remind you all that eastbaygreenhome.com has a lot of resources on the resource page and details about each home that you view today on the sites page, SITES. And here is today's program. So we'll start with a presentation about heating your air and water without burning fossil fuels. So let's do this test again. Can I see a show of hands? First one is, who heats their home with a gas-powered furnace? All right, thanks for your participation. Okay, and then you can lower those hands by clicking raise hand on the bottom again. Thank you. And second question, who heats their water with a gas-powered water heater? All right. Seems to be more of you on that one. Thanks for participating. If you can lower your hand. Great, thanks for that. So the vast majority of us who live in the Western US heat our air and water with gas-powered appliances, which are major sources of air pollution and greenhouse gases. So heating and cooling air and heating water are the activities that require the most energy in our homes. So how do we get our needs met without polluting our cities and destabilizing the climate? That's the question. So it is my pleasure to introduce our first expert, Amy Dryden, who can answer that question. Amy is the Director of Strategic Innovations at the Association for Energy Affordability, where she also spearheads research projects on indoor air quality, health, electrification, and advanced energy technologies. Amy has more than 20 years of experience in green building design, construction, consulting, research, and planning. And when not working to advance healthy housing, you can find her out with her boys paddling, on her bike, or driving her all-electric 1946 Ford pickup. Welcome, Amy.
Oops. Thank you very much. Good morning, everybody. Thank you for joining us today. Going to, if the host could enable screen sharing and video sharing, then I can share my screen and start the presentation.
There you go, Amy. Thank you.
Perfect. Okay, well, I can share my screen, can't do video, but great to see you all today. Thanks for joining us. Thank you for the nice introduction. Got a lot to cover in a short amount of time, just to kind of level set a foundation of heat pumps for space conditioning and water heating. And as was mentioned, I'm with AEA. We are a nonprofit located in Emeryville, and our role in this world of decarbonization spans from program implementation throughout the state, as well as R&D to look at emerging technologies and bring them into the mainstream, as well as training and codes and standards and policy support. So we're kind of have our hands in a number of buckets to help us on this pathway. So if I can set up a nice conversation of like, we're talking about electrification and where do we use residential or gas and electric in residential buildings. So first, water heating. These are kind of high level estimates of percentage of our uses, gas usage in the home. So about 49% of our gas usage is water heating, 37% is space heating. Then we've got some cooking, maybe pool, spa, miscellaneous things in there, drying for many of us. And so these are all the buckets we've talked about. And I know last weekend there was a lot of discussion on cooking. And so today we're going to talk about space heating and water heating, because the reason why we're going in this way for all electric, and Amy set it up nicely, and I think you had an introduction last weekend, about the multiple benefits here. So from safety, from eliminating NOx and CO in our homes, to improving our indoor air quality, to achieving our climate goals, both locally and statewide, as well as improving our resiliency. And also, if you think about utility costs long-term and the opportunity to offset our utility costs, our electric utility costs with renewable. I'm going to go through the next couple of slides like this one pretty quickly because I think they're they should be kind of a refresher from other conversations. And so I want to get to the heart of it. Just to put this in context here, that this is not kind of a flash in a pan. There's been a lot building in this way. So even in 2020, with our 2019 code, we had an all-electric pathway for residential, low-rise residential, which was huge, making it much easier to build all-electric. And you can see 21 today, we have over 40 jurisdictions that have all-electric new construction ordinances. We have CCAs and utilities looking at carbon-free electricity and offering that option. And as we kind of look forward to the future, these policies that are kind of driving activity today, we have 50% of our renewable electricity, or electricity is provided by renewables by 2030, and we're doubling our energy efficiency. And if we look to 2045, where we have 100% zero carbon electricity and statewide carbon neutrality. So all of that being said, these state policies are driving incentive programs that Amy mentioned, training, to get more appliances, to build capacity within the market, and to expand the ability to deliver all electric, low carbon retrofits and new construction to our industry. I just put this one up here quickly and highlighted, because we're talking about the East Bay, the number of East Bay jurisdictions that have adopted some kind of ordinance driving toward all electric. So just highlighted them in green because this will be recorded. You guys can have this reference later. So we can kind of cut to the chase of space conditioning and water heating. But there's over 42 jurisdictions who have adopted ordinances. So we really can do it with all electricity, with all electric. Again, you heard about cooking last weekend. We're talking about space heating and water heating. And there's appliances and products on the market to address laundry, pool heating, and fireplaces. So it is possible. We can do it with really, particularly on the retrofit side, with smart retrofits, where we're improving the efficiency of our buildings, reducing domestic hot water demands, and servicing all those end uses with high efficiency appliances such as these, and that we'll talk about in just a moment. So before I go into specific technologies, I'm going to give you a 2-minute primer on heat pump basics. So these are all heat pumps. They should look familiar to you, these appliances, right? Our refrigerators, water fountains, window AC units, and on the right here, we have an integrated heat pump water heater. So essentially, you can see all of these are moving cold air to hot air in some fashion or the other, depending on the intent of it. And so this is what a heat pump does. You're never going to say that at a cocktail party or at a gathering. That's a little more complicated. What you need to know is it moves heat from one place to another using a refrigerant. It's that simple. It's like an air conditioning, like a refrigerator, right? Our refrigerators are expelling heat, right, into our kitchens. Air conditioners are pulling heat out of our rooms and expelling it to the exterior. And so it's really just a simple process, and I'll just mention this quickly. If we think about kind of our high school physics days, going back to that, as we think about moving things from high concentrations to low concentrations, it's pretty basic kind of principle here. So really, when we're looking at heat pumps, we're looking at high pressure. So you can see on the right, and it's moving through and it's being compressed. And when we compress things, they get hotter, right? So they can gain heat. And then as things move from high pressure to low pressure, when we release that pressure, they can release heat. And so it goes through the cycle of high pressure to absorb heat, lower pressure where it can expel heat, and it will run through that cycle of that refrigerant cycle, either drawing heat from the inside and expelling it like an air conditioner, Or in the reverse, as we talk about heat pumps with reversing valves, you're going to be bringing heat into the home. And so you'll be pulling heat from the exterior and bringing that into the interior of the home. So why do we really like heat pumps so much? Couple of great things, they're super efficient. If you look at heat pump ratings, they're about 3 to 5 times as efficient as our gas products. Even our most efficient gas furnaces, like the condensing furnaces, some of us may have in our homes. Those are like 98% efficient. Heat pumps and heat pump water heaters are greater than that. An electric resistance water heater is 100% efficient. A gas water heater that we also may be used to, the gas tankless, is like 76, 78%. I'll talk about water heaters in a moment. They enable zero emission buildings. Because they are electric, we can offset them either with on-site generated clean energy or if we are getting clean energy from the utility. They improve indoor air quality, right? Because we're not having combustion in our homes. We don't have gas lines in the building. We can also deliver heating and cooling with a single system because these heat pumps have a reversing valve. They provide heating and cooling. And there's functionality to work in different climates. And we'll talk about the different configurations of these systems that can address different existing buildings. So let's talk briefly about heat pumps for space conditioning. And I know kind of following this, there'll be tours of different homes with these different systems in it. So first off, we have ducted heat pumps there on the left. That kind of outdoor unit may look familiar to you if you have been in a home with air conditioning, right? You have that large kind of cube for the outdoor air, for the air conditioner. And then you have an indoor air handler. Well, in this case, for the heat pump, unlike our traditional outdoor condensing units that provide AC only, this has a reversing valve, and so it's providing heating and cooling in conjunction with that air handler that's installed inside, so outdoor, indoor unit. The next column there is mini split heat pumps. Those can be ducted or ductless, and so it's similar to the ducted heat pump you hear, the split system you see on the left, but it's more of a suitcase size outdoor unit compressor you can see here in the middle. And then it can be paired with a variety of different systems within the house, from like a slim duct register to an air handler to a ductless system right here where this cassette is on your wall. So there's a variety of configurations there. The vertical terminal heat pump, I put it in there. It's really more on the hotel side or kind of large multifamily side. It's very similar to the PTAC in the next column there, which may look familiar to you if you think about like the hotels you've been in. What we're seeing now is really efficient, well-designed package terminal heat pump systems that can go in the wall. They can sit proud of the wall. They can also sit in between the stud bay and kind of be recessed. They're incredibly efficient. They go through the wall, so they're really good for smaller spaces, one room, you know, maybe an addition that's not kind of connected to the other main portion of the home or something like that, smaller spaces. So there's a variety of conditions or systems that can meet different existing conditions. And I also want to touch on combi systems because you'll be hearing about them through the Harvest Thermal project. So combination system means it's providing both space heating and water heating, and in some cases space cooling with one system. So a hydronic system. I've got the sand in there on the left. I'll talk about that in a moment. And a Chiltrix there on the right. But again, it's one system with an outdoor and indoor unit that is providing domestic hot water as well as hot water and potentially chilled water to meet your space conditioning needs. And again, those can all be met with a heat pump. So just an illustration, just to show this is more illustrating kind of what I was talking about in terms of the refrigerant cycle. On the left, you can see here, it's extracting the cool air, expelling it to the outside. We're pulling the outside air across that coil to warm it. and delivering warm air in interior. So this illustration here is just showing one of those simple ductless cassettes on the wall. And on the summer, it's doing the exact reverse, right? We're extracting the heat from the inside and expelling that to the outside while we're bringing cooler air into the interior. So it does this with the refrigerant lines and the refrigerant cycle. So some things to consider as you guys are thinking about this, and as you're listening to the different tours, you can hear where selection made sense for different home configurations, loads, and needs. So first off is feasibility and constructability, like what can be installed. I showed you a variety of options that can meet different loads and building considerations and conditions. And so as you're looking at what's available, what space is there, what's the load, certain maybe the package thermal heat pump is a really good option, or maybe you're really looking at, a slim ductless, ducted mini split. This also may be informed by electrical capacity. You're going to be hearing about smart panels later. We're often thinking about that load calculation, and so we can think about what systems can fit into an existing panel or be accommodated if I happen to be doing a panel upgrade. Can also think about costs, right? First cost, maintenance costs, and lifetime costs. Our lifetime costs should be going down for electricity, particularly as we look at future rate changes, as we look at the contribution of PV to offset our loads. And last but not least, you have to think about AHJ, which is authority having jurisdiction, right? Who is authoring those permits? So there are some considerations in terms of visibility from the street for that outdoor unit. Are there considerations for setbacks on where you can locate that outdoor unit on the side yard? Are there particular noise ordinances? These are pretty quiet. If you think about the traditional cubes that I was talking about before, the AC units, those are like 79 decibels. When we're looking at these smaller compressors, they're like 42 decibels. They're even quieter than a heat pump water heater. But these are all things to consider. And also we want to minimize any exterior mounted refrigerant lines, and that also can be a consideration from the jurisdiction, maybe from a planning or aesthetic level. And let me go to heat pump water heaters now. There's two different kinds that we can talk about. You can see one on the left is the split heat pump water heater, where I have my tank is separate from my compressor, my outdoor unit there. This is my outdoor unit, which gives some flexibility in terms of installation opportunities. And on the right, I have a number of systems that are all integrated. And so here, as I'm looking at this, my water tank is here, and what's on top, right here in the black, is the compressor, right, where it's pulling air across that condensing coil, extracting that heat, warming that water. Okay, so I have two different kinds of system. I'll talk about some considerations in a minute. Again, all of these are electric. They employ storage tanks, have you seen? Most have a heat pump, right, that compressor, and a resistant element. A resistant element is the electric resistant element. Really, we look to operate them to maximize the heat pump operation because that is the most efficient, right? It's just moving heat from one place to the other, and only utilize the electric resistance element to really address higher draws, additional capacity when it's needed as like a boost. Some, like the split system, don't even have an electric resistant element. I just want to point this out here because there's a lot of questions. Really, under the 2019 code, you can install heat pump water heaters, and they can replace the gas storage water heaters. I saw a number of you raise your hands that you have a gas water heater in your home. Just calling this out because it has been something that has evolved in the code over time, and really the code is encouraging heat pump water heaters in new construction. So a couple of things on installation, and then I don't know if we have time for questions, or I can answer questions in the chat. So a couple of things. Most require 240 30 amp electrical supply. Some of them are 240 15 amp. We do have some coming on the market that are 115 to 15 to 20 amp, kind of a retrofit ready for smaller loads. And that's really looking at how to balance out achieving all electric homes and minimizing capital improvements or electrical infrastructure upgrades. So we're having new product to address that. Unlike our gas water heaters need makeup air, heat pump water heaters require also access to adequate volume of air or ventilation, because again, if we think about its functionality, it's pulling that air across that coil to extract the heat. And so the manufacturers have recommendations of 750 to 1,000 cubic feet in that room. And you need to make sure that the vents are not blocked, they have access to that water, that air, excuse me. The preferred location is more in hotter areas like a garage, again, because we're trying to pull that heat out of the air. And so warmer places result in higher performance. It does have a condensate drain that's only water, unlike condensate drains from combustion appliances that include byproducts of combustion. This is solely just water that's condensing on the coil that we want to remove from the water heater. And typically we're looking at larger storage than our gas. There's a higher recovery time, a longer recovery time for heat pump water heaters. So it may have a larger recovery time and larger storage. Other considerations are sound and venting. The way the heat pump water heater works, again, it's pulling air across, through here and extracting cool, dry air. And so if you have the water heater located in the home, you may want to be venting that cool air out of the house to not inadvertently impact the space temperature, the indoor temperature. And there is sound considerations. I would say the sound is, like I said, about 55 decibels for a high performing NEA rated tier 3 water heater. And that may be equivalent to like your refrigerator, maybe a dishwasher. And so you can think about that location of that water heater to minimize that impact. You can also think about how it's operated, the compressor, when the compressor is operating, to also minimize that impact. So I have 2 slides left here. A couple considerations. I talked about location. You want that sufficient makeup air. We want to make sure we've got venting. You want to minimize compressor noise. I also want to call out, you want to use high performing equipment. The energy code is also pointing toward NEA, which is Northwest Energy Efficiency Alliance, tier 3 rated heat pump water heaters. They have lower decibel ratings. They can be configured with demand response. They're higher performing. They have a higher COP. Generally, I think it's a minimum of, I think it's 3.2. So you can look for selecting higher performance equipment. The third bullet I really want to call out, if you're installing a heat pump water heater, install a thermostatic mixing valve. That allows you to heat your water in your hot water tank to a higher temperature than you want it delivered at your tap. So I can heat it to 140 degrees as an example. I deliver it to my tap at 120 to prevent scalding. But now that tank, maybe my 50-gallon tank, heated at 140 degrees now becomes 83 gallons because I'm heating it to 140 and mixing it down to 120. This can really help us with load shifting. You'll hear about this with other configurations and other systems, particularly Harvest Thermal, when we look at heating to a higher temperature. So I just want to call that out. And you can reduce demand with most efficient distribution if possible, and water sense fixtures and appliances. So lastly, in closing, just want to say, a number of jurisdictions are passing ordinances that favor it. The building code is moving toward all electric. Gas infrastructure is, going to be a stranded asset. And as we start moving to building electrification, we may think our electric rates are high now, but electric rates are evolving. We're seeing all electric rate design occurring today. We can offset it with renewables, and we're going to see increase in gas rates. And so it's going to become continually more affordable, and we already talked about kind of healthier and more comfortable for our homes. So hopefully I didn't go too far over, Amy.
No, thank you so much.
But wanted to get through a number of things.
Yeah, no, there's so much to get through. I really appreciate you doing that. I appreciate the research that you do to also shine light on all the options, and to help people figure out what their pathways are. I know a new heating system is a big investment, and the choices can be really daunting. So hopefully, this kind of cues people up to sort of identify some of the different heat pumps that they'll see today in the different homes. And Amy, you can definitely dip down into the chat and the Q&A to answer questions that you see that popped up during your presentation. And so now I'm going to do screen share, and we're going to go to the first video. Our first home belongs to Karen and Danny, and it's in the Berkeley Hills. Karen is retired from nonprofit fund development, and Danny is a retired psychologist. And their home greening process has been very steady. They make one upgrade to their home every year. And they have a unique system that Amy mentioned, which combines both air and water heating into a single heat pump. And Jane Melia, who is the CEO of Harvest Thermal, she makes a cameo appearance in the video to explain the system, but she's also going to be available for Q&A afterwards. And I see that she's been busy in the Q&A answering a lot of your questions. So let's go ahead and roll the video.
Hi, welcome to our home. My name is Karen Harrington. This is my husband, Danny Weddy, and this is little Eli, our 2-year-old grandson with us. We actually have a 4-generation home, so we're quite blessed for that. We have lived here in the North Berkeley Hills for 8 years now. I came from Southern California, and Danny came from Missouri and San Francisco. And, we settled here and have been so happy in this wonderful community and neighborhood that we live in. Our goal, since we have lived here, is to become a more sustainable home, to have a greener presence. And so about once a year, we do some project to achieve that in our home. We work with 350 Bay Area, 350 Bay Area Action, and the Climate Reality Project. So we are very aware of the consequences of runaway climate change and are concerned about that. So it has been a goal of ours to lower our carbon footprint. We think as individuals, or we know as individuals, we can lower our carbon footprint by being more efficient and all electric. Okay, so this is the heart of our system, and we recently had it installed. And this is a way that we combine our heat and our hot water into one system using one heat pump. And we are a beta site for Harvest Thermal. So we're one of the first systems, and we're very excited to be so cutting edge in our quest to really lower our emissions and move the technology forward.
As I said, I'm Jane Melia, and I'm the co-founder and CEO of Harvest Thermal. And what we're trying to do is help homes transition to the cleanest electric heating and hot water in a way that's very comfortable and affordable. And of course, we've got to really cut those carbon emissions. That's what we're really focused on. And the reason we're doing that is that in the Bay Area, heating and hot water represent about 2/3 of the emissions from every home. So moving your home away from gas heating and hot water is probably one of the best things you can do to really cut your carbon footprint. So the Harvest Thermal system is made up of our pod, and this is a pilot system, so it's in 3 boxes. But think of it as one pod that we stick on the wall, and that's the brains of the system. The Harvest pod operates the heat pump, which is outside, and make sure it runs times when electricity is clean, cheap, and abundant. Typically in the middle of the day. Most of the electricity from the grid in California at lunchtime is solar. So we operate the heat pump, and that generates hot water. The hot water goes into a tank. In most homes, you only need 1 tank, but Karen and Danny, they've got a big home with a lot of occupants, so they have 2 tanks. So you store the hot water in the tank, and that hot water is used later on either to heat your home and to deliver your hot water. So you're completely decoupling the time when you buy your electricity from the time when you deliver your heat. So by doing so, you're always able to capture the solar electricity to run your heat pump, and yet you use your heating and hot water in the evenings and the morning whenever you need it. And so even compared to a standard heat pump system, we reduce emissions by about 60 to 80%. But what's really important, and what's really important for us to have an impact, is that we're also cutting people's bills, because when the system chooses to use electricity when it's also the cheapest. So this is a Sandon heat pump. It's an air to water heat pump, and it's basically the most efficient heat pump out there. I really love heat pumps. What they do is it's almost magical. They bring in heat to your home by moving heat instead of generating it. So if you think about your gas furnace, it has to burn gas to generate heat. So it's always going to be less than 100% efficient. Because it's moving heat, heat pumps are over 100% efficient. In fact, this heat pump, the specified performance of this is 500% efficient. So just one heat pump is generating heating and hot water, and it's so much more efficient than any gas appliance. Another nice thing about it, as you can see, it's quite compact, but it's also super quiet. In fact, in my home, it's right underneath my daughter's bedroom, and she never hears it at all, which is really nice.
Look at some of the improvements to the home that we've been doing in the last few years. Okay, so this is inside the house, and you had a chance to see our system. But when it comes in, it looks just like any heating vent that you would have, any heating register in your home. So our heat comes through here. We have a night cooling system with harvest thermal that also comes through here. And something that's really, I think, important about this system with what we're seeing with these wildfires is it also has a very high quality filter system to filter out the smoke in the air or any kind of pollutants. So that's something very important these days, and unfortunately where we live. Okay, this is our induction range. It's an induction stove top and an electric oven. It's Fisher Paykel, and it's a 36-inch. There's not a lot of induction ranges you can get on the market yet that are 36 inches, so we were pretty limited on what to choose. One of the reasons that I like this one is because I do a lot of cooking, and I love the arrangement where I have 5 burners, and I can bridge 2 of them so they have a really big heating space. And Eli's going to help us because Eli likes to cook with me. We cook together a lot. So it was important to me to go with induction for our all electric home. As you may have heard, cooking with gas really emits a lot of harmful chemicals in our home and harmful gases, and one of those is methane. And I have a 2-year-old here who is said he's with me all the time. We make pancakes together. We make a lot of cookies, don't we? And so I feel so much better that we now know we have a clean kitchen for him to be in. Okay, and this is our electric fireplace, which is, it's terrific. It's our fireplace for ambiance, and it's also a heater for us. So I have a remote control that I can use, or I can have a switch right here, and it turns on, and it's beautiful. It's 3D, and I think it looks just like a fireplace, like a gas fireplace or a wood fireplace, but no emissions. And it's pretty efficient. And it's a heater. I can turn the heat up or down. We can change the colors. My husband and I don't always agree. I like a real looking fireplace, and he likes a little more excitement in the fire, so we can both be happy. And we've got the mantle from Omega Salvage, so it's a very old mantle, and that was in perfect condition. And then we kind of searched around for some tiles that we like. So we're really happy with this part of going all electric. Okay, this is our new ventless heat pump dryer, and we bought it also with our washer, so it's a very high efficient system. And how it works is it actually pulls it, instead of heating up, instead of having a heater, the heat pump draws the moisture out. So it takes a little bit longer, but the efficiency, the amount of energy that you use is maybe a quarter of what you would use in a typical electric dryer. Okay, what you're looking at here is the plumbing system that's connected to our wash machine and to our heat pump dryer. So the water that comes out of this system goes into our plumbing pipes that you're looking at there. And we have that lever, and the lever is turned to the left. And so all the water that comes out goes through a pipe under our house in a crawl space, and it goes to our front yard where there's a system where it waters our yard. So it's a gray water landscape, gray water laundry to landscape system.
We've had our hot tub for about 3 years now, and didn't want to give up everything when we went all electric. So we do have a separate electrical unit for the hot tub, and it's a luxury that we're simply not willing to give up. It's special to us. We enjoy it a lot, and we're out here a couple nights in most weeks.
Okay, this is one of our rain barrels. We have 5 rain barrels in the backyard, and they each hold 50 gallons. So 250 gallons total. And one of the parts of the system that we're really pleased about is 2 of the barrels, this one and one on the other side, are fed from rainwater. The other 3 are fed from rainwater and our irrigation system. We have an upstairs deck, and that irrigation system, it feeds, it waters the plants up there, and then comes down, and that water goes into the rain barrels. So it's we're able to use these rain barrels 12 months out of the year. And they have a faucet on the bottom of them. So we use buckets, and we use them mostly to water all of the plants we have in pots, and also to supplement our drip system. It's a pretty high efficient use of our water system. So our plan is eventually to put actually some pumps. You can put pumps inside them so that you have more pressure to get the water out. We haven't done that yet. Next step. Okay, so we have had our solar array on our roof. We have 18 solar panels for about 5 years now. And this is the newest part of the system. And we just got approval from the city of Berkeley probably 3 weeks ago. And we're thrilled to have it. It's battery backup for that system. We live in the hills, and I'm sure as many of you also have, we live through these devastating wildfires. And we know it's just a fact of life that these will continue with climate change and increased heat and drought in the state of California. So what will happen if PG&E has a rolling blackout, or if it's just a blackout and we're not informed ahead of time, is this battery backup will kick in, and it's always fully loaded at 100% until we actually need it. And when our power is shut off in PG&E, I think it's less than a second actually that this will kick in. And friends who have the system have told us they don't even know that power is off in their neighborhood because it's happened so quickly. Your clocks don't go down, your computer doesn't know what happened. So it's very efficient. We have 4 batteries in this case here, and this is the inverter, the brains of the whole operation. So we are excited to have it, and have no doubt that it's going to work. We did have to do a little bit of work with our electrical panel. This panel here is our battery essential panel. So every time that we have to go to battery backup, everything in here will work. So our all of our outlets in the house work, our refrigerator stays on, all of those kind of essentials that you need will still be in operation.
I got my first e-bike about 3 years ago, and my wife got one shortly after that. We love it. I had not been on a bike since I was 10 years old, and I got my e-bike when I was 70. And so I had some trepidation about riding a bike after 60 years of not having been on one. And I knew I couldn't handle the Berkeley hills without an e-bike, but it turned out to be a great purchase. I absolutely love it. I go out 2 or 3 times a week, and things that I used to use my car for, I now use my bike for. We go to the post office. I pick up necessary items for dinner, milk and so forth on my bike. And oftentimes I just go out on Sundays and go for a 20-mile ride because it's fun.
Okay, so 3 years ago, we got our first electric vehicle, a Nissan Leaf, and this is our charging station that we have in the garage, and it's right next to where Danny charges his EV bikes. So we have all electric transportation in our home also. Okay, thank you so much for attending this green home tour today. We are thrilled to be part of it. And I hope we maybe gave you a little bit of inspiration and encouragement to also look at ways that you can lower your carbon footprint in your home. And as Kermit the Frog says, it is easy being green. We did it on a gradual basis, and it's been an exciting project for us, and we couldn't be happier with the results.
Karen sort of led the way for us, and like many other liberals, I gave lip service to the importance of reducing my carbon footprint. And then I married this woman. She walks the walk. She made me a true believer, and I'm proud of what we've done so far.
Okay, thank you so much to Karen and Danny for opening your home up. I just wanted to honor that, you know, a few years ago, Karen and 350 Bay Area did the first electrified home tour, which unfortunately I was out of town, but I really wanted to do it. And so I am so glad to be highlighting her home for more eyes this time around. So welcome, you guys.
Thank you. We're happy to be here.
So between then and now, what have you seen change between the time that you did the first electrified home tour and now? Are you seeing a changing landscape?
It's actually, we are, and it makes me optimistic about our future. The home tour was about 3 years ago with 350 Bay Area. And we wanted to highlight that it was important to have increase your energy mix to be more clean and sustainable, and to get rid of gas. You know, we use gas to heat our homes for hot water and for appliances, and it makes for, it's expensive, it's dangerous, and especially in the kitchen with cooking, as you heard from Amy and saw in our video, it makes for extremely poor air quality. And you know, we're cooking with kids, and it's not a good idea. Yeah. So yes, we have seen a lot of change in the last 3 years or so, and Amy mentioned it. 46 jurisdictions in California now have passed an ordinance that all new construction is all electric. No gas lines to these homes are being built. So that is incredible progress, and it's continuing. Of course, the challenge is most of California's homes are not new. And so it's how to retrofit these old homes. Our home is almost 100 years old. And so these unique homes sometimes take a little bit of unique solutions. So that is the challenge. How do we at scale and reduce cost move this electrification forward?
Yeah, so you, with your harvest thermal system, you are one of just a handful of pilot sites. And I just wondered what went into your thinking about being an early adopter. Like, what made you decide, like, you know, there's not a lot of these out there, but I want to go and choose to be an early adopter.
It was really an easy decision, actually. On that home tour you mentioned earlier, 350 Bay Area, we one of the homes on the tour used Harvest Thermal, and it was Jane Malia's home, who is the co-founder of Harvest Thermal. And we both toured the home and were just so impressed how it uses one heat pump for heating hot water and heating your home. And this really increases your efficiency. I don't remember now. Jane will talk about how many times more efficient it is, and that impressed us. And we were impressed how it worked in their home. So we said, you know, sign us up. We are ready. And every time we'd see Jane, how's your beta testing going? We are ready to hop in. And so we did. And we actually launched earlier this year and have been very pleased with the results. It's a great system. I highly recommend it. And it's fun. It's fun to be on the cutting edge. You know, everything is software updates, so things will improve and we don't even know they happened. And that's the future, right?
We kind of pushed ourselves into the queue. I think Jane got tired of having us ask, when's our turn coming?
Nice, nice. So we have Jane here today. Peng, I was wondering if you could spotlight Jane Melia as well. And Rebecca, could you let us know what kind of questions are happening in the Q&A?
Sure. There's actually lots of questions. I want to just remind folks that questions for the presenters would be best if you put in the Q&A, and then the chat can be for general back and forth. But we've got, after each speaker, our presenters will go back in and try to answer them, but it's harder to find in the chat. It gets lost. We are saving the chat also. A number of people have asked, and we're looking into if we can save the Q&A. And for Jane, I'm going to ask, I know we're a little tight on time. So someone wants to know, is your system coming out of beta soon?
Yes, we're going to be deploying our first 30 systems at the end of this year. And the goal is to deploy 100 or more by this time next year. So we're going to be opening up for commercial sales, probably reaching out to our contacts later this summer to see who's interested in signing up for a deployment this time next year.
That is fantastic. And Jane, there's also questions for you if you can take a look in the chat and the Q&A. Amy, just let me know when we need to hop on to the next one. But we've got questions, Karen, about your battery. They want to know what battery you installed. How long does it last on the system? Because you've got a lot of systems running there. So if you could just maybe respond to that.
I'm forgetting the name of the battery. Do you remember? It's boy, I wish our contractors here. Do you remember, Jane? It's I will put it in chat, and or if there's a question in the Q&A, I'll put it in. But it's one of the reasons we chose it. It's a local Berkeley company, and we really like that. And it's a local contractor, Hot Watts. We interviewed several people, and that was the two reasons why we chose that system. How long does it last? We haven't used it yet, but I think it will last, at least a couple of days, because what happens is our solar system will continue to feed it while we're down. So it's probably more than a couple of days. It will last, our longest power outage so far has been 2 days, I think, and we would definitely outlast that. So yeah, I think it's a great system.
Okay, well, we should probably move along and go on to our next home. But I just wanted to thank you guys, Karen and Danny, and also Jane. And also I wanted to thank 350 Bay Area for pioneering the first electrified home tour, and also for being so supportive on this one as well. So it was great to meet you guys.
Thank you for hosting this.
Enjoyed being part of it. Listen to this and then
Okay, now we head through the tunnel to Lafayette and the craftsman that Wei Tai and his wife Violet had built in 2004. Wei Tai works in the solar energy industry and is co-founder of the Bay Area chapter of the Climate Reality Project. Their house has several features that you probably haven't seen yet, including green flooring options, sink twice, and a metal roof. So let's roll the video. Sorry about that. I just made it high definition.
Hello, my name is Wei Tai Kwok, and welcome to our home here in Lafayette, California, which we built back in 2004. I live here with my wife Violet and 2 children who are now in college. And a little bit about me: during my day job, I'm in the solar and renewable energy industry. And for my volunteer work, I spend a lot of time working for the Climate Reality Project. Now, this home was constructed on a bare lot back in 2004. And frankly, my wife and I, we knew nothing about building a home. And so we made a lot of mistakes, but we did want to build a green home as much as we could back in the time. The good news is that today, although it was maybe a little harder back then to build a green home, today it's actually quite a bit easier. And there's so many more green technologies that I'd love to share with you, some of the retrofits we've been doing the last 2 to 3 years to actually make our home today a zero emission house that runs fully on 100% renewable energy. As human beings, I think we operate on the assumption that moving away from fossil fuels is very hard or it's expensive.
or that it'll take a really long time. But is that true? Back in 2012, we installed solar panels on our roof and changed LED light bulbs and even purchased a Nissan Leaf electric vehicle. And I thought at that time that was about as much as I could do, because I assumed that it was difficult and costly to get rid of the natural gas infrastructure inside my home. However, I discovered I was misinformed. I started researching and learned that all electric homes, which use high efficiency heat pumps for heating and cooling and water heating, were cheaper in the long run because they are 200 to 300% efficient versus my 58% efficient water heater or 90% efficient furnace. It actually only took me 45 days to get rid of all 4 of my fossil fuel appliances and convert to an all-electric home. I wish I had built my house all electric in the first place. It would have been more comfortable, healthier, and more cost-effective. Now, the electricity used to power our home comes mostly from the 15 solar panels on our roof. But the remaining 40%, actually, we get it from the grid, and our community choice energy provider is MCE. And we've opted up to the deep green 100% renewable plan from MCE. So I know that every month when I pay my bill to them for the grid electricity, those dollars are used to procure California wind and solar electricity. And that's what gives me the confidence that between my own solar panels and MCE, our home is 100% powered by renewable energy and therefore is a zero emission home. We used to have a gas fireplace here, but we've retrofit that to install an all-electric fireplace. Now, the gas fireplace here in the Bay Area, we actually only used it like twice a year. And so we decided to do something more simple with an electric fireplace. There are many, many beautiful ones out there, but we decided to just get an electric log set. So if you take a look here, there's a LED lighting for the logs, as well as, if you can see the flames in the back, that's actually a projector. It's a projected image of flames. And so it really just creates the ambiance we need for a focal point in this room. It doesn't not generate heat, although it could if we wanted to, we could turn that on. But this was a very effective way for us to do a low-cost electric fireplace retrofit of our gas fireplace.
I was skeptical about going electric because I really like my gas cooktop, but actually induction works great. And we picked the Frigidaire 36-inch professional cooktop. It has 5 burners. And one of the reasons we picked it is because of the kind of old-fashioned knobs. But the numbers are in a digital display of the numbers. So it's very easy to use. You turn it from, starts high, and then from 9.0 all the way down to 1.5 and then low. So it's very responsive. And this is our everyday pan that we use a lot. It's a non-stick. So we can do a lot of our stir fries and other dishes in this pot. I think we find that it works very well. And this one actually, you do need to match up the pan actually to the burner. And so this one actually usually sits right here. So that's usually where we have the pot to do the cooking. One of the huge benefits actually, which I didn't realize was with induction, is the ease of cleaning. And you basically just wipe down the glass surface with a sponge and pretty much everything comes right off. It's fantastic. I love it. This is much easier than my gas cooktop, which was much more of a chore and I really dreaded cleaning. So this is a benefit that I really love about the induction. And then the other benefit, actually the other advantage, is the improved indoor air quality. Cooking on induction actually doesn't emit any air pollution, which gas does. So I think for those reasons, I'm so happy that we switched to electric.
Now, our home used to have a central heating and air conditioning system with ducts, but we retrofitted to use heat pump mini splits. And so we got 8 of these wall units to attach to the heat pumps outside. And the great thing about them is that they're all controlled by remote control. I've turned it on to heating right now, and I can feel a lot of warm air coming out to warm our house. And the benefit of having 8 of these units is that we only need to heat the rooms that we're actually in. So at nighttime, we just heat the 1 bedroom and not like the whole house. And so that makes it a lot more energy efficient by having those 8 zones for heating and cooling. And we've noticed that that is able to help save on our electricity bills. All right, let's check out the heat pump mini split in the bedroom here. I'm going to turn it on, and you can see how the remote control will open the louvers and start putting out hot air from the vents right there into our bedroom. I want to show you some of the carpeting and flooring we used in our house. And this particular flooring is made by a company called Interface and a brand called Floor, F-L-O-R. And it's great because they are one of the most sustainable carpeting firms in the world. And one of the things we like about it is that at the end of life of this carpet square, you can ship it back to Floor and they'll fully recycle everything into new carpets. But if you ever get these dirty, you just go wash them off. Or if they get stained, we have a couple extras and you just plop them in here. So it's just that easy. And believe it or not, they actually do stay down perfectly well. The great thing about a bamboo floor is that it's made from a very fast growing grass rather than wood, which takes a long time to grow. So it's a much more renewable resource. In just 5 to 6 years, you can create bamboo flooring like this. So we really like that idea of using something more sustainable than wood, and that is bamboo. Well, this is one of the most popular things in our house for sustainability, and that is our toilet, because it's a flush and wash toilet, where after you've done your business, you're going to come in and you just flush here, and then you can wash your hands here with some soap, and just wash hands, and this water is going into the tank, which will be used to flush the next time, and therefore you'd save 2 gallons of water each time. We had a 75-gallon gas hot water heater for our house before, and we replaced it with a heat pump hot water heater, which is using this heat pump technology here to warm up water outside, and then send it into the house to be stored in a new 83-gallon tank. This unit is a little bit different from the normal ones because it's a 2-piece unit. It's 1 piece here and then the tank indoors. But most of the heat pump hot water heaters on the market are actually single units, which have the whole thing inside the house. Now, this is the heat pump running our air conditioning and cooling. And I want to just show that it's actually not too noisy. One thing I was worried about was whether or not the fan would be loud or not. But I'll stop talking and you can sort of see it's not that bad. This year, we also replaced our asphalt shingle roof with a metal standing seam roof. And one of the benefits of that is that it's more energy efficient and fully recyclable at the end of life. It's actually more energy efficient because it's less heavy and less mass, and so it absorbs less of the thermal energy from the sun in the summer compared to asphalt shingles. And my wife and I, we definitely noticed during those hot spells in the summer that our home was noticeably cooler because of the better insulation factor of a metal roof. Also, metal lasts a lifetime, and rather than just every 20 years replacing our roof, it was something that we felt we could keep all that asphalt out of the landfill and use metal, which is fully recyclable. All right, and here's how my electric car charger, which is connected to my solar system, and we're gonna plug it in here to the front of the Nissan Leaf. It's a 240 watt charger, volt charger. Here we go. And in about 3 or 4 hours, the whole car will be charged up and ready to go with 100 miles or so. Now, part of our retrofit involved adding the insulation to our building envelope to be really airtight. and doing sealing of the ceiling and so forth. But that meant we needed mechanical ventilation to be added. So we got this HRV, heat recovery ventilator, and that is something that helps to bring in fresh air from outside, but it also transfers some of the warm air from indoors, so it's not all just wasted outside. Well, this is where my gas meter used to be, right here. Here's the gas line from the street, and here's the line that goes into our house. And I'm happy to say that after we retrofitted our home to get rid of all fossil fuels, we were able to remove our gas meter and disconnect from the PG&E gas grid. And originally, I thought this was like an impossible thing to do, but it turns out that we did it in just 45 days. So if you think it's impossible, then like I thought it was impossible, I hope that you'll be inspired to know it's not impossible. And if I did it, you can too.
Okay, great. Thank you so much, Wei Tai. I see you there. Peng, could you go ahead and spotlight Wei Tai? Hello.
Hi there, everybody. Good to see you.
I wanted to do a quick shout out to Eco Performance Builders, who Wei Tai used for his heat pumps, and they're an excellent company who is also one of our sponsors, and one that I always highly recommend to people who are interested in this process. Wei Tai, yours is the only home that has a metal roof, and a lot of times I think that people don't think of typical East Bay roofing as being a big topping of fossil fuels on top, or I should say petroleum products on top of your house made from asphalt. But also with increasing fire danger, metal roofs are also really good at being fire protective. And I was just wondering what led you to consider a metal roof, and how does that connect to your climate work?
Right, that's a great question. And, you know, asphalt shingle roofs are the most common roofing material used in Northern California. And that's why we put it on our roof. It's inexpensive, you know, 15 years ago, but I was surprised that a 40-year warranty, despite the 40-year warranty, after just 15 years, it was already starting to fail. And so, you know, a friend of mine said, why don't you get a metal roof? And something I never considered before. That's a standing seam metal roof that you saw in the video. And it turns out that, of course, it is fire protective to be metal, and asphalt shingle is as well. But, you know, just from my postman said when he saw my roof, he said in his volunteer work, when he's gone out to fire areas, he's seen like lots of homes burned down, but the ones with the metal roofs were still standing. So I don't know if that's like urban legend or what, but he commented when he saw our house change in that fashion. The roof is like 2.5 to 3 times more expensive than asphalt shingle, but it does last a lifetime rather than, I couldn't imagine every 15 years I was going to replace my roof. That asphalt shingle was going to go into landfill. There's only one recycling facility for asphalt shingles in the Bay Area near the Oakland Coliseum. And therefore most roofers just, you know, don't want to drive that far. They just throw it away. So I thought that was completely irresponsible to have that much in the landfill.
Yeah.
So anyways,
a lot of waste. I also wanted to mention that that people who do rainwater catchment, rainwater that is flowing off of an asphalt roof gathers a lot of debris that you actually don't really want in your water that you want to put on your plants. And so a standing seam roof, if you're capturing the water, it's just a lot higher quality. All right, Rebecca, what kind of questions are we getting in the Q&A?
Oh my goodness, so many questions. First, I just have to say people are loving your carpet and your roof and your floor. They even want to know what paint colors you're using. So again, after the presentation, if you stick around, please, and go into the chat and the Q&A, there's a lot for you, but a lot of questions about the roof. People want to know, is it louder when it rains?
Yeah, we get asked that question all the time because I guess, but the answer is no, it's totally silent because the metal roof is attached onto the wood sheathing, right? So it's very solid. And, you know, in other places where you do see a metal roof and there's no sheathing behind it, then you hear the ding, ding, ding sound. But when it's attached right onto the wood, there's no sound at all.
Great. Amy, do we have time for one more or should we move on?
Yeah, one more, go ahead.
So this is a question that I think is actually applicable to all the homes out there, but I guess at some point you mentioned, you know, sealing. for an all electric house. And so the attendee wanted to know, does this mean that you don't open your windows, or is this only during hot and cold weather? Can you talk more about what you mean by sealing?
Yeah, so sealing meaning air gap sealing, is that the question? Like
I think that's what they're talking about, but they didn't know, what is that? What does that mean to seal the home?
We built our home. Yeah, we built our home only 15 years ago, and surprisingly, there's been so many advancements in building performance, that term building performance, and learning how to make a high performance building. And one of the key insights is that our home should be airtight, right? We don't want to spend lots of money to heat the inside of our homes, only to have the heat rise and leak through all the gaps in our lighting fixtures and so forth. So great way to save energy. And in modern homes being built now, the best homes are highly sealed. It's the building envelope is almost like a vacuum, so that you don't have your cold air and your hot air that we've spent money on to just leak out just like that.
Thank you. And another question I see is coming up in the chat that I can just answer right now. I said, do you have to open walls to do sealing? And the answer is no, that you can seal from the inside, you blow it in, you can seal from the outside. There are lots of options. Thank you so much. It was really an inspiration, and you got a lot of questions for you in the chat.
I'll be happy to answer the questions in the chat, and then I'm going to stay around till after 1 o'clock during the an extra session. So if people have further questions, I'll be here live at 1 o'clock.
That's right. Thanks for reminding us.
Yeah, thanks, Wei Tai. I was about to say that. So stick around, because Wei Tai is one of the experts, and he's also a professional in the solar industry. And so in the extended Q&A, if anybody has questions about solar, Wei Tai is a good person to.
I'll do my best.
Aim those questions at.
Yes.
Okay.
Thank you, Amy.
Thank you.
And thank you, everybody.
So now we're going to turn to the Berkeley home of Tom Graley and his wife, Janie. And Tom is a retired engineer who now spends his time promoting the electrification of Berkeley homes and co-chairing the Berkeley Electrification Working Group. And one of the things I like most about Tom's home is that it retains its original charm, and that you would never know that he has these like really modern systems that are running in an otherwise like very enchanting little bungalow in Berkeley. So let's go to the video.
Hi, I'm Tom Graley, and this is my house. It's a 1,200 square foot Berkeley bungalow. To my right is my electric car, and on my roof is my solar panels that charge the electric car. We started our electrification process of the house in 2016, doing a little bit at a time. We're almost there, almost completed it. So let me take you on a tour. This is our 200 amp service panel. There's another service panel in the basement that was part of the original 100 amp service. We had to upgrade to 200 amps when we installed the heat pump heating and cooling system. And so now we're going to go up on the roof, and we're going to let the drone take us up there. We'll see the solar array and the heat pump. Our first electrification step was the solar array. We started with a 2 kW array and later added another kW because we converted to an electric clothes dryer and added an electric vehicle charging station. Our latest electrification step was installing a heat pump for heating and cooling our house. This is the compressor. We will see the air handler when we go into the basement. The reason we put the heat pump on the roof was because we were on a very narrow lot. The city required that the unit be set back from the house, and we didn't have the space. We could have put it in the back of the house, but that would have meant a very long refrigerant line running through living space. So the roof was the answer. The light-colored roof reflects sunlight and helps keep the house cool. Below that roof is our new R44 insulation, which is doing a great job. In order to install the insulation, we upgraded the knob and tube wiring, removed the old insulation, cleaned out any debris, and then blew in the new material. Blue Rock Home handled the cleanup and the blow-in and did a great job. R44 insulation really is quite thick. This is the hatch or the door to the attic in order to get up, and that's how tall they had to make it in order to put R44 in the attic. Since a lot of the participants came to this presentation via the Bring Back the Natives garden tour, I'm going to take a minute to describe our garden. In addition to producing our own power, we like to produce our own food. The garden is a mix of edible plants and ornamentals. The summer vegetables include tomato, pepper, garlic, lettuce, beets, eggplant, beans, and rhubarb. The winter garden usually includes cabbage, broccoli, cauliflower, and Brussels sprouts. We also grow spices like oregano, French tarragon, parsley, cilantro, and chives. For berries, we have strawberry, blueberry, berry, and raspberry. The trees are apple and persimmon, and I've started to replace some of the ornamentals with natives. So far, I have skullcap, checkerbloom, and California poppies used for ground cover in the front. Okay, let's take a look in the kitchen. This is the one point where we haven't fully converted to electricity. We still have a gas stove, but we are ready for an induction stove because we've already installed our 40 amp electrical outlet when we did our upgrade to the 200 amp service. Right now, we continue to use an induction cooktop unit here and electric teapot as well as the microwave. While most of the food preparation takes place here, we do have another spot where we brew kombucha. It turns out that this is the warmest place in the house, and the kombucha brewing process really is facilitated here. The registers you see are original, but the ducts were replaced in about 1990 when the furnace was replaced. This house, when it was built in 1929, had a furnace which might have burned coal. At least it was a conversion from a coal furnace into a gas furnace. And that furnace continued in use until 1990 when it was upgraded to a modern gas forced air furnace. We use about 1 therm a month in gas usage. It now costs more for the gas service than it does for the gas itself. Our next stop is the laundry room and the utility room. Let's go to the laundry room first. In 2017, we had a bit of a gas leak in the laundry room. There's a gas line that fed a very old gas dryer, and unfortunately, the gas line was buried underneath the concrete, so it was going to be very expensive to replace. So we decided to upgrade to an all-electric dryer. We already had an outlet, so it's an easy upgrade. The dryer works very well. The only issue is it does use a lot of electricity because it is a resistance dryer. So let's head to the utility room. This is the utility room. This unit is our air handler. The heat pump compressor on the top of the roof sends either cold or hot refrigerant down into this unit. The unit transfers the heat from the refrigerant or the coolness from the refrigerant into the house, into the air through the ducts. We also installed a HEPA air filter. The air filter has been a real savior during the smoky season and fire season that we have. It absolutely clears the house of all that smoke and makes us feel much, much better. This unit is our 50-gallon heat pump water heater. 99% of the time it operates in heat pump only mode. On the occasion when my extended family comes to visit, we put it into hybrid mode. And at that point, it uses not only the heat pump, but also resistance heat to meet the demand. And one last step before we conclude this. This is the electric vehicle charging station. And right now it's already plugged into the car. And so we're taking the power from the solar panels and putting it right into the battery. It took us a little over 3 years to accomplish what I've just showed you. Our utility bills have either been slightly negative or just a few tens of dollars per year. Our clothes are dried, our food is cooked, our water is hot, and the temperature of our house is either cool or warm or however we'd like it. We're very close to being a carbon-free home. You can do it too.
Okay, thank you so much, Tom. Are you here? Can you get a spot?
Yes.
Can we get a spotlight? There you are.
Hello.
Hi. So, you know, I was really interested because I live on a very narrow lot myself. And so, you know, a lot of the heat pumps that I saw on this tour were, you know, close in to the back of the house or close into the side, but you ended up with one on your roof. And is that typical? Like, do heat pump companies know how to do that and that's not unusual? You know, how did you figure out that this was an option for you?
Well, basically, I saw heat pumps on many roofs in the Central Valley. It turns out that it's much more common thing to do there. And also, I guess it's called manufactured housing. Though a lot of times we'll have the heat pumps sitting on the roof of those houses. Also, we already saw a heat pump on the roof with Danea's apartments.
That's true. Yeah.
The heat pumps were already up there on the roof. And so from a commercial point of view, it's really quite common to put air conditioning units, heat pumps on roofs, especially on commercial property. And so my decision was based on, first of all, I couldn't put it along the side of the house. There just simply wasn't enough room. I could have put it in the back, but as I said in the video, this refrigerant line would have landed up running somehow through a bedroom, through a closet, and then into the utility room. And I just, you know, a couple of people looked at me and said, "You really want to do that?" And I went, "No." and so I did have to look around for somebody who was willing to put it on the roof, and I finally found somebody. And then came the question. A couple of the vendors I talked to said, "Oh, you're going to need a structural engineer to make sure that the roof can handle it." And that kind of made me a little nervous. So I actually did talk to a structural engineer. I described how big it was and what the roof was. He goes, "Nah, don't worry about it." And so I talked to an architect friend of mine. He said, "Put a few boards up there." And so I actually had a little bit of structural support added in, and just to make sure. So I was completely comfortable doing it. It was, you know, a couple-hour job to put in some boards.
So Rebecca, what kind of questions do we have in Q&A right now?
Sure. Oops, sorry about that. Tom, I'm going to follow up on your roof. Jack wants to know if you had any problems getting the heat pump compressor approved by the city's seismic codes when you tried to get permitting for it. Two-part. And another, and Susanna wants to know, who did you use to put that heat pump up?
Okay, so I got a permit from the city. The city inspected it. There were absolutely no issues whatsoever with seismic was never mentioned. Let's put it that way. There was one minor issue from the inspector. He wanted a locking valve on the refrigerant line. And so we put a locking valve. The people I landed up using were, I had a neighbor who worked for a company called MCOR, which is a commercial heating and cooling HVAC company. And I hired his employee to do it on the weekend. So I had a moonlighter install it on the weekend. And so that was, I don't really recommend it, but if you're kind of a do-it-yourself kind of person and you want to get involved in it and really, kind of do that kind of stuff, then it can be done. But that's what I use.
Thanks, Tom. I know, folks are asking about incentives, and so our next speaker from BayREN will talk to us about it. And in that case, you don't want to use someone who's moonlighting to take advantage of those.
No, you don't.
Right?
As a matter of fact, I just got a rebate from BayREN for my insulation that I just put in. So that was very nice.
That's great. Another one last quick question. This is about your heat pump dryer that you're using. Larry wants to know about lint deposits. Larry was reading that some people have to take apart their machinery every 2 to 3 years to remove the lint that gets past the dryer's lint filters. Have you had any problems with your lint filters?
I have a resistance dryer. Ask
That's
Amy.
right.
Amy would be the person for that.
I apologize, Tom. I was answering questions in the chat while your video was going, and I do remember you saying that is the part that drains more electricity. So maybe Amy, if you could, when you hop back on, I know we're about ready to roll.
Sure.
Any problems with lint?
No, not at all. Not at all. I change out lint every, a lint filter every time I do it, just like you would in any other dryer. And the other thing is there is an extra lint place that I maybe switch out once a month. But the great thing with heat pump dryers is that a lot of the fire hazard of gas dryers is the buildup of lint in the vent, and a heat pump doesn't have a vent, and so that fire hazard is just gone. So anyway, sorry to cut in there, Tom, but that's the word on the heat pump.
You were the one with the answer and experience.
All right, how about one more question for Tom?
Okay, let's see. Can you just explain the difference, Tom, between an electric resistance dryer, which you have and I have, I know, and others, and the heat pump dryer that Amy's using?
Okay, so an electric resistance dryer is really quite simple. There is an element in there, the electricity comes in, and creates heat, and the heat dries the clothes. There's a fan in there, and the clothes are tumbled, and the fan blows hot air across the clothes to dry them. A heat pump operates differently in that it takes, again, there's a fan that would be blowing through the clothes into the compressor, and the compressor uses the compression and expansion of gas to remove heat from the clothes. And so you will actually have that air move in through the compressor and the coils to bring it out. It's the same exact way that a refrigerator works or HVAC works, except that it's using air to go through the clothes to extract the heat from that. And so water does come out of it. So you will end up with a heat pump dryer with water that's usually boiled away. Right, Amy? What happens to your
what happens to mine is that there's just a little tiny tube.
Audio.
Sorry. Do you hear me? There's a little tiny tube that comes out of the back of my dryer, and I just stick that tube into the drain pipe that my washing machine drains into. So it's not a big deal. It just is a little trickle that goes down into there. So thank you so much, Tom. And now Peng is going to introduce our next expert speaker.
Yeah, thanks so much, Tom. And a quick shout out to, give me one sec. So a quick shout out to Blue Rock Home, who recently did Tom's installation. Tom, echoing everybody in the chat, you had a have a beautiful native garden. And just a quick reminder to everyone who's joining us today for chatting and asking questions. If you're chatting, just make sure you're chatting with everyone if that's your intention, if you want everybody to see what you're chatting. There's also just an option just for panelists. And so that's up to you. And then if we're asking questions again, a reminder is just to put it in the Q&A so it doesn't get lost in the chat. And there's also the Google form that's Rebecca is also dropping into the chat. So now we are going to feature our next expert, Joseph Kaprensky from BayREN. And BayREN is an acronym that stands for Bay Area Regional Energy Network. And it's an agency that provides energy efficiency programs, services, and resources to all 9 Bay Area counties. And home upgrades cost money and sometimes quite a bit. So there are big rebates out there that help bring those costs down and to help incentivize you to do those upgrades to save water and energy. And BayREN is ground zero for, give me one. BayREN is ground zero really for tapping into those rebates and also for finding contractors to help you make those changes. And so I am pleased to introduce Joseph Kaprensky, who's going to walk everyone through BayREN's free services and rebate programs. Joe is the contractor services field manager for BayREN's Home Plus program. He engages with contractors to help them enroll in BayREN's programs and of course, makes sure that their work is of high quality. Welcome, Joe.
Hi, thank you, Peng. And can everybody see my screen here? Just want to make sure that the slideshow is up on the screen. Is that look okay?
I can
awesome.
see.
Great. So yeah, thank you everyone. And certainly thanks for everybody for joining. Thank you to our presenters today, Karen, Danny, Tai, Violet, Tom and Jane. Sorry if I'm missing anybody that I did jump on a little bit late, so I may have missed an earlier home that was showcased, but certainly, thanks for letting us into your homes and showing us the great work that you guys, have done and continue to do. I know certainly with the BayREN Home Plus program specifically, we rely on early adopters like yourselves to sort of test the market, do those types of upgrades before the general public sort of catches on, because we then use those demonstrated savings to help develop these energy efficient programs and start putting incentives behind these types of upgrades. So just wanted to echo that. But yeah, without further ado, we will get started here. So like Peng mentioned, who is BayREN? BayREN stands for the Bay Area Regional Energy Network, and it is a collaboration of the 9 Bay Area counties. So it's funded by ratepayer dollars that are overseen by the California Public Utilities Commission. So if you receive PG&E service and you reside in one of the 9 Bay Area counties, you would be eligible to take advantage of some of these rebates and free service offerings that BayREN has to offer. Specifically, we are talking about the single family program, but we do have also green labeling as it relates to the home energy score. And also there is a multifamily program as well for units that are for properties that are over 5 units. So we'll just talk about some of the benefits of participating with BayREN. You can be eligible to receive up to $5,000 in cash rebates for a variety of home energy efficient upgrades. You'll receive support and guidance from our energy advising team. We'll talk a little bit more about this on a later slide, but we do have an energy advising service where you could call in and receive advice from a trained energy advisor. They are familiar with the technology, the rebates, the contractors, the whole process. They're not in any way a salesperson, so it's sort of a good starting point when you're considering embarking on one of these home electrification projects or just any home upgrade project in general. You could reach out to them and receive some unbiased recommendations. and make your home more comfortable, safe, and healthy. And we're also reducing greenhouse gas emissions and improve our air quality, certainly as the Bay Area transitions from natural gas to cleaner alternatives. And BayREN does have electrification specific rebates that are designed to help transition, towards decarbonization for our existing buildings. Certainly, we have ordinances in place for new construction, but we want to make that pathway possible for the hundreds of thousands of homes that we already have in the area that were maybe not built with energy efficiency in the forefront. So the next couple of slides are just going to go over some of the rebates that are available for the BayREN Home Plus program. This slide, so we do have operations and maintenance measures. So there would be $150 rebate for smart thermostat installs. Anytime you're replacing ductwork or just sealing the ductwork, there's rebates there. Certainly, Wei-Tai, you had mentioned the importance of sealing up your house and lowering that heating and cooling load as part of the project. So we do have rebates for attic insulation, wall insulation, exterior wall insulation, and also building air sealing as well, which we talked a little bit about. Heating and cooling upgrades. So there is a $300 rebate for a gas furnace. We have sort of, that rebate has been reduced from one year to the next as we, sort of transition towards an electrification focused program. The rebates for high efficiency heat pump equipment is on the rise, and those gas rebates are getting lower and lower. Certainly, we want to provide more incentive for electrification options. So as you can see, there's a $400 rebate for a gas water heater, but a $1,000 rebate for a heat pump water heater. Also, heat pumps. So if you're going from a central gas furnace and central AC to a heat pump system, there's rebates available there. And again, with the heat pump water heater, it's a $1,000 rebate, whether you're going from even if you have an existing electric resistance water heater going to a heat pump water heater, there's a rebate. Or if you're going from a natural gas tank or tankless water heater, there would be a $1,000 rebate available. And yep, for the electric range and cooktop, if you're installing one of those, it's not something that we require a contractor to install. You could purchase the unit, have it installed, and then go online and apply for a $300 rebate for the cooktop and a $300 rebate for the heat pump clothes dryer as well. And we do have some bonus incentives available to sort of help incentivize, taking a whole home approach to the project. So if you were to combine a building shell measure like insulation or air sealing with a heating or cooling upgrade, we'll pay an additional $500 for that project. Same with the insulation. If you are insulating your attic and walls simultaneously, there's an additional $500 rebate available there. And there's also an incentive to downsize your existing equipment. So reducing the amount of BTUs that the system is putting out. There's a $100 rebate there. And also combustion appliance safety test, $150 incentive. The majority of projects that apply for rebate in the BayREN program require what's called the combustion appliance safety test, where a BPI certified professional will go out to the home, and if there is any gas appliances that are left in the home, like a gas oven or a gas water heater or gas furnace, that certified professional will test that equipment thoroughly just to make sure that there's no carbon monoxide issues in the house, or that the systems aren't producing excessive levels of carbon monoxide. And they also test the draft of the system just to make sure that those gases are leaving the house adequately. So certainly a cool test to have done if you do have any combustion appliances left in the house. So in addition to the BayREN rebates, there's also some additional layered electrification rebates out there. So community choice aggregators, or CCAs, offer additional incentives when converting from natural gas hot water heaters to high efficient electric heat pump water heaters. So I think Tai, you had mentioned you were enrolled with Marin Clean Energy. So they are one of our CCAs that offer an additional incentive for heat pump water heater natural gas conversion. So if you're enrolled with Marin Clean Energy and you have a heat pump water heater installed and you apply for the $1,000 BayREN rebate, there's an additional $1,000 rebate that is kicked in from Marin Clean Energy for that same project. And so there's Marin Clean Energy, who's one of our CCAs, who has an additional heat pump water heater incentive. There's East Bay Community Energy, Sonoma Clean Power, and Peninsula Clean Energy. So depending on where you're located throughout the Bay Area, there's additional incentives that are potentially available to you. And certainly something one of our energy advisors can give you more information about. And you can also go to the BayREN.org heat pump water heater website, and there's more information on the rebates that are available, as well as the contractors in your area that you can work with. So often when we're talking about rebates, the conversation for financing often comes up. So there are some options that are available, in California. One of them is real financing. And this is a loan that you can take out. It's a very low interest loan, and they do have a very lenient credit score. I believe like 580, 600. They'll still, they'll approve the loan for green energy projects. Contractors do need to be enrolled with real financing. So if you're already working with a contractor, you can encourage them to follow the link there and get registered so that they can offer the financing on your project. And there's PACE financing as well, which is also a similar program where the payments will actually be added onto your annual tax bill. So that's certainly another option that you could discuss with your contractor. So there's also, we're going to talk a little bit about electrical service panel upgrades. So usually when you are doing a project or a home electrification project, it's, I got my daughter here with me. But so yeah, certainly in older homes in California, there are ways to avoid panel upgrades. And sorry, I got my daughter behind me here. But newer homes, typically, they may require a service panel upgrade for more than 100 amps. And as we, look at these electrification project or programs, we're looking towards offering more incentives for panel upgrades. So that's something to look out for in the future. Currently, we have Peninsula Clean Energy that offers an incentive for service panel upgrades. So sorry, I'm gonna just 1 second. I'm going to pause my video, and I just gotta 1 second.
Hey, maybe while he's doing that, let's see a show of hands. How many of you have had your kids get in on your Zoom during COVID?
Sorry about that, guys. I'm back. So yeah, next steps would be to reach out. Like I mentioned, we have our home energy advisor service. There's the phone number there. And like I said, you could reach out, and no matter where you are in the process, if you're just starting out, or if you're in the middle of the process, or a home upgrade, retrofit. Sorry. I'm sorry. I'm so sorry.
Hey, everybody, I just want to mention, this is Amy here again. I just wanted to mention that I am always pointing people to BayREN as a good place to start out for figuring out their first steps and also for finding contractors. And I want to mention that Joseph will be part of our expert panel at 1 o'clock today for the extended Q&A. So stick around for that if you want to hear him answer some questions from the Q&A. And I also wanted to remind you that links to BayREN are on the eastbaygreenhome.com resource page. So whenever you hear stuff during the tour today, remember that you can go back to that website, and a lot of the links to resources or details on the homes can be found there. Hi, Joseph, you're back.
Hey, yeah, sorry about that.
No worries.
My wife is currently taking her MBA, and it's today's the day where, you know, she's taking a test, and, you know, we have her daughter, and so it's our schedules got a little conflicted today, but
no worries at all.
You know, but yeah, I mean, this was the last slide that we're on. Let me just resume. So yeah, we have the, you know, our energy advisor service, and you could also go online to the BayREN residential website and fill out a quick evaluation where you could learn sort of some easy tips and tricks on how you could save on your energy bills. And you could also receive a free energy kit in the mail as well, with, you know, some light bulbs, a smart power strip, you know, that sort of stuff to help reduce some of the load as well. And yeah, schedule work with one of our participating contractors. So in order to qualify for the BayREN rebates, the work does need to be installed by one of our participating contractors. And when you connect with our energy advisor, certainly they could share out the list of contractors that are available in your area. For East Bay, we have 73 participating contractors. So, and they, you know, they range from installation to general contractors, electricians, heating, ventilation, and air conditioning specialists, plumbers. So yeah, certainly. And if you go onto also the BayREN residential website, you can, there's a find a contractor web tool where you can specify the language that you speak, the territory that you live, the work that you're looking to do, and then a list of contractors will show up, you know, based on that search criteria that was filled out. And yeah, once the project completes, the contractor will submit for the rebate on your behalf, and myself and contractor services, you know, we work with the contractor and the homeowners, you know, throughout the rebate process to help ensure the project that there, you know, if there's any issues on the application itself, will help sort of, you know, remedy those.
Sounds good. Okay, well, thank you so much, Joseph. And if you can stick around to answer some questions in chat, and I'm just going to remind folks that Joseph is going to be on our panel of experts at 1 o'clock too, if you want to make sure that you stick around for that. So now we're going to go to our next home tour, and this is the home of Stephanie Frugal. And those of you who that are coming to the Green Home Tour from the Bringing Back the Natives Garden Tour probably know Stephanie, because she's very involved with that event, but also has a fantastic property full of native plants, and that is just an oasis of biodiversity and resilience. And between her huge rainwater catchment tanks, her smart panel and batteries, you get the feeling that she could thrive quite well through drought, heat waves, power outages, you name it, any kind of crisis. She will be happy on her oasis. So I'm going to go ahead and share the screen, and we will run the video.
Hi there. My name is Stephanie Krugel and I live in San Leandro, close to downtown. This house is a 1946 house and I've lived there for 5 years. And I'd love to show you my green features, so come on in. So I want to talk a bit about the bigger idea here. And I've been really troubled about the environment and habitat loss, especially. And in a way, what we try to do is just be less bad. So what I wanted to do is really like do something good, like give back in a way. And my yard, that was the main reason I bought this house, because as you can see, the house is pretty small, has a large yard. It was all dead grass and weeds, really not much happening, bunch of sparrows, and I've turned it into a wildlife garden, and now have a lot of different species coming here. I see a lot of insects. I really feel like it's added to what was there before. And you know, with the house, it's sort of similar. I mean, I'm trying to get as close to net zero kind of impact as possible, and trying to, with the solar, you know, use my own electricity and also simplify, so it's not so much in the first place. And I have to tell you, it's really empowering. It doesn't feel like a sacrifice at all. So I want to show you the heating, the space heating I've changed. I have here my old wall heater, gas wall heater that a lot of you probably recognize. It's not in use anymore, but I wanted to show it because it's like a museum of the bad old days. And I actually got an electric heat pump. It's a mini split ductless heat pump. And I'm going to show you what that looks like. I have 2 units, indoor units. So one's over here. They're both sort of at the ceiling and one in another room, and the exterior unit is outside in the yard. And I really like this a lot because it puts out continuously warm air that has time to blend with your indoor air, rather than the old unit that would just like heat up fast. The heat would just go right under the ceiling and then it would cool off again. So this being very low electricity use, I can leave it on and it just creates a much more comfortable heat indoors, and it also cools. So this is my bedroom and I don't have any heating in here. I like to sleep kind of cooler at night, but I do have a ceiling fan for some nights that are a little hotter, and then I can turn that on. So my bathroom's really small and I didn't want a whole heating unit in here, but sometimes, you know, in the morning it is really cold. So what I have in here is a sort of a convection regular space heater. It's really cool. It's flat. I actually got it used on Craigslist, and it has very low voltage, so it doesn't use a lot of electricity, but it is just convection. And because I just need it in the morning, I actually got a little smart plug where you can basically, it's like setting a timer on an app. And so I set it to start warming, say 6 in the morning. When I get up at 7, it's kind of toasty, but the rest of the day, then I don't really need it. So that way I also get a warm bathroom. So I wanted to talk a little bit about consumption also in terms of energy savings, because all the stuff we buy, you know, there's like all this embedded energy and all the resources. So I'm big on that, and it has become kind of a lifestyle. Like I just think about, well, I want an item, can I get it used? Do I really need it? Can I get it without packaging? So on those notes, I just wanted to show a couple of things that I've come to really like, especially around preventing extra packaging and disposable plastics. So I have my little plastic bag dryer here, and you know, these freezer bags, they're really sturdy. There's no reason not to use them more than one time. So I just rinse them with when I do my dishes, and I have them dry here. So that's been really handy and cheap and easy. And if you come around, I also want to show you another thing I actually got from a friend. It's a secondhand yogurt maker, and I make my own yogurt, and so I don't have to have all those plastic cups that, you know, with the recycling is very questionable, and also save a bunch of money. So welcome to my garage. This is actually where the battery lives for storage for the solar that you saw earlier. And this is the solar inverter.
and we're gonna move over to my electric hot water heater, heat pump water heater. And I'm happy to say that I actually got pretty big rebates for that one. So here it is. It's pretty much as large a tank as the old gas water heater was, and has the heat pump in here, and it also stores hot water. I have to say, zero difference in user experience to what it was before. Always have hot water, no problem, but much lower electricity. This is where the cold air gets discharged out. So this is my clothes washing machine. It's an Energy Star and a front loader, and it has very low water usage and electrical usage. And I really like the front loading because it's much more gentle on the clothes. And now we're gonna go check out my dryer. So over here, this is my dryer. Here's my rainwater catchment system. I have 3 tanks, each is 1,000 gallons, and they daisy chained together. You can't see it because there's a lot of stuff sitting there, but basically from only part of the roof, it comes down through the gutter. That's sort of the first flush that takes out the dirty water and then funnels into the middle tank, and as it fills up, it fills all the tanks simultaneously. So right now, I hear how full they are. They're almost full, and so I have 3,000 gallons of water that I harvested over the winter for my yard. So over here you see how I'm actually using the water. I have a hose attached, and the white pipe in front is the overflow, and the pump you see in the back there is just a small 1.5 horsepower pump to get the water all the way into the back of the yard. So let's take a look at my smart panel here, the span. And here's what everybody has, the circuit breaker panel, and the span panel replaces this. So I have a battery storage for my solar energy. And with this panel, instead of a regular circuit breaker panel, I actually have a lot more flexibility in terms of where my energy goes. So my priority is to use as much of my own energy as I can. So I load shift, which means during the day when there's sunshine, I charge my battery and then I use it at night, and of course also during blackouts. But with the smart panel, each circuit is its own thing on an app that comes with this smart panel, and I can direct what I use. So for example, I have certain circuits set for a blackout situation. Say there's no grid, I only use my battery, and you want to be very conservative with the available electricity, right? So you only use certain circuits like the fridge, your router, your garage door. But with the span panel, I can change that in real time. It tells me, oh, you have 80% battery, you'll be good for your important circuits for 2 days. Now say I know it's just gonna be a day. Oh, I can add the hot water heater, for example. And so it just gives me a much better flexibility to traffic control my own electricity. And it also helps me know exactly how much stuff uses. It tracks everything. And we're going to show you a couple screenshots to see what the app looks like. And I just have to warn you, if you get this, you're going to spend a lot of time on your app because it's fascinating. So thanks so much for visiting and checking out my green home. And I just want to encourage you to embark on that journey to get fossil fuels out of your lifestyle. And I hope you got inspired. It's certainly been very empowering for me, and I'm happy.
Okay, that was Stephanie. Stephanie, are you here?
Yep, I'm here. Can you hear me?
I can. So good to see you again.
Good to see you, Amy.
You know, one thing that's really cool about you and your home is that you kind of embrace sort of both extremes in terms of you have like really low tech stuff like your bag drying or your clothes drying on the line, but then you also have sort of the most modern, electrical panel equipment. And whenever my son Jude and I visited you, the span panel was sort of new to you. And so now you've had a little bit, some weeks to play around with it. So I'm kind of curious, what does having that much sort of visibility and control over your energy usage, what does that feel like? How has that been for you?
Yeah, I really love it. It's been fascinating. And when you guys came to visit, I was like on the app like every single day because I was just kind of like exploring it and just figuring it out. And I can reassure you, after a while, you do get sort of the hang of it and it becomes more of a habit. So it's not like the super time consuming thing. But as I mentioned in the video, each circuit has its own picture, if you will, on the app. So you can see at any time, is it on, how much is it using, at what time? So you really get a sense of what electricity different things use and at what time. Like for example, that, and my eye is kind of watering, so sorry about that. I'm not crying, although it's also moving that I might have. So say that little bathroom heater, it actually turns out to use as much electricity as, say, the space heat pump.
Wow. Okay.
So I'm like, ooh, yeah, that's kind of like, because it's not heat pump, it's kind of, traditional heater. And so you just kind of dial it in, or maybe you use a little less, or I can see that my toaster oven, it creates the spike, because when you have like your toast in there for that minute or two, it's like 800 watts that's using. So it really allows you to understand your usage a lot better, and also decide when you use certain things. So as I mentioned, I basically right now, I'm really net zero, because I either use the sunshine energy as it comes in, I use it in real time, or I use it from my battery. I've never, and we haven't had a blackout yet, knock on wood, but I've never like run out of battery. But that's also because when the battery is on, which I can see in the app, I see exactly where my electricity is coming from at any given minute. I don't run my biggest users at that time, or I'm very sort of deliberate about that.
Yeah, you in the next two homes, something that comes up a lot are people who are starting to, when you have that much awareness, you also know when electricity is cheapest, during the day. And so I'm starting to see and hear from people who really play with that. Like, what are they going to do with their excess solar energy at the peak of the day, or when are they going to run their heat pump so that they get the cheapest rates. All right, so Rebecca, what kind of questions are we getting in the Q&A?
Hey there, Stephanie.
Hi, Rebecca.
So it was really neat to just see that mix of low tech and high tech. We've got a lot of people commenting on it in the chat and the Q&A. But here's a real simple question. So we noticed, you have a washer and use solar dryer, use the sunshine. So some attendees want to know, what do you do during the winter months and during the rainy season when you need to dry your clothes?
Yeah, so I don't run a ton of loads because it's just me, and I really make them full. So I kind of like have my closets in the hamper by the time I finally wash. But I just hang it up inside. I have these two smallish racks that fit about one full load, and I just have it literally in my living room or in the garage, and it dries just fine. I mean, it's really amazing how fast right now that it's nice out, like really in no time.
That's great. A number of questions about your span and your battery. But here's one. Dorothea is wondering, if you have an existing electrical panel, can you just kind of add the span functions to it, or do you need to basically, in essence, replace your whole panel with a span panel? They've already they have a relatively new electrical panel, and so wondering if they can make use of it.
Yeah, yeah. So my understanding is what you saw in the video is really sort of a relic there. It replaces it. There is no combining it. That would not really make sense. So traditionally, and it's just mind-boggling when you think about it, how ancient that technology is, that we upgrade our panels. We essentially say you get solar and you've had gas before, so you don't really have sort of the lanes, the infrastructure for these new electrical circuits, right? So you need to upgrade your panel. So you build on extra circuits, but only because when an outage happens, you need these dedicated lanes to have your dedicated circuits. So it's very rigid and it's kind of overbuilding just because it's so inflexible. So the span panel completely replaces that, gives you your original panel and then some, but it lets you just choose which circuits are on, which are off. It just gives you full control. So it's kind of a bummer if you have a fairly new panel. Mine was really old, but the cost is also interesting. Wasn't even that much more because the panel upgrade's pretty pricey.
Yeah, I know that you're one of the, you're one of the first, or one of the few that have actually put in a span panel, and a neighbor of mine who just got a solar system did it too and loves it. He works from home, and so he was concerned if there's a power outage, he needs to have, the backup. So he did that with a battery. Let's go after your span. If you have time afterwards, if you can go into the Q&A and the chat, you'll see questions for you.
No problem, sure.
There's one question though about your rainwater barrels. They're wondering if you're also collecting any gray water from the house, or is that just rainwater?
It's at this point, it's just rainwater. I have thought about the gray water, but it's kind of, I don't have that much. It was a more important investment to do with the rainwater, also because, I have a big yard. So, but I'd be curious about gray water as sort of a future action.
Stephanie, your yard is an inspiration. I have a small house and a big yard, but mine's full of weeds. But I'm going to drop a link into the chat that I did before. It's actually the city of Berkeley has a gray water site. So there's a difference between laundry to landscape, which you don't have to permit. It's a really simple system to catch your laundry water to use for irrigation, and then a gray water system, which is using your shower water. And that does have to be permitted. So I'm going to just drop that link. And there's also, at the very bottom of the webpage, there's some more resources about gray water and rainwater collection.
And if I can just add a quick note on the rainwater collection, because this is something I learned. So as you guys saw, I have 3 very large tanks, 3,000 gallons. And I was lucky that my house had this concrete area on the side. I think people parked extra cars there or whatever. So it was perfect because you need a stable solid ground to put those tanks on. But it's not just about getting that water so you have it in the summer, because this year we had so little rain. We had like 40% of what's normal, so my tanks barely filled up. But in past years they'd fill up twice, so they'd overflow at some point. And even if you have a small barrel, like say you only have like 500 gallons or whatever, it's really important to let it fill up, then let that water out into the backyard, fill it up again. So it's not just saving for the summer, but keeping that water on site, like you're replenishing the ground. Because right now, if you have that one downpour, and we're getting these more extreme weather patterns, water runs off, it needs to stay on and get absorbed into the ground. So then in the summer, it can replenish itself from below, if you will. So it's sort of like a cycle and soak. So I was just going to encourage people considering rainwater barrels, tanks. If you don't have that much room, as I do, still do it.
Yeah, thanks for that. What is the saying? I'm sure I'm going to mangle it. It's like slow it, sink it, spread it.
Yeah.
With water and re-upping the water table.
What one sort of for us gardeners, and I that is just my biggest passion. And one thing you can do is also kind of like berms or shape your backyard landscaping so it just holds the water in, those rain gardens that are really just depressions where the water gets captured and then has time to trickle in. So there's some very simple things to help that.
Great. Well, thank you so much, Stephanie. I really, it was a pleasure to meet you and to be in your lovely home and your super lovely yard.
It was great fun to do that video with you, Amy. Thanks to Jude. And I'm gonna answer some questions in the chat now.
Okay, great. So now we are gonna go to the home of my friends, Sach and Suzanne. We met each other watching our kids play soccer together over the years. Sach is the policy director for Vote Solar, and Suzanne leads a nonprofit for healthcare reform. And I just wanted to say in advance so that you notice when it pops up is that they have a heat pump water heater. It's the only one that I saw that wasn't in a garage or a basement. It's just in a closet right off the kitchen, drawing hot air out of the attic and blowing it into a shed. So anyway, I just wanted to put a pin in that so that you notice when it pops up. And so we were going to go to the video now.
Hi, my name is Sach Constantine. Welcome to our home. I live here with my wife and 2 sons. This is a typical Berkeley bungalow built in 1906, right after the earthquake in San Francisco. Probably housed people fleeing the disaster of San Francisco at the time. We moved in about 15 years ago, the end of 2005, and we've been working on this house ever since. All right, so one of the first things you should know is that I work in the solar industry, and so I'm very motivated to convert to renewable energy. And one of the first things we did on the house, and you'll see it on the roof, is put solar panels on. This is actually the 2nd generation of solar panels on the roof right now. These are SunPower panels. I wanted a more efficient panel because I don't have a lot of roof space that's exposed to the sun. But that got us started. Once we put those solar panels in, we of course wanted to make the most efficient use of our energy. That's part of my job as well. Started putting in better appliances, started even insulating the walls, replacing windows. And then a few years ago, we did a full remodel, and it was a chance to really make the move to an electrified home. One of the reasons we moved into this house in the first place is that it's in a walkable neighborhood. There are stores of all sorts that we can walk to. We don't have to drive. Our kids can walk to school. They can walk to all their schools. And then building on that with the solar and the efficiency, and now the electrification has been both a project of the heart, but also a very intellectual exercise for me, because it's part of what I do, part of my work to combat climate change and promote things like energy justice and equity in our electricity system. Yeah. Let me show you around. So you're coming through the foyer into the main dining room. In here, a couple of things that we've done in the remodel, well, besides wallpapering and my family's maple syrup jars for lights, we used the old cold air return and the old ductwork, and you can see the registers here just set even with the floor and wood panels. We used all this old system to hook up to our heat pump. So we put in a heat pump HVAC system to replace the existing gas furnaces that had been there. And there had actually been 2 units in this house. There had been a sort of an in-law on one side and the main home here. And it had been combined probably sometime in the 50s, the late 50s, into a single home. And we combined the furnaces from both houses into one. We have a smart thermostat attached to that, and the house is zoned for different climate control in each area. So I mentioned the smart thermostat. We actually use the Ecobee, very similar to a Nest. Smart thermostats hook up actually relatively easy to your home heating system. We have two Ecobees here. They're both synced to each other. They give us outside weather readings. They give us the indoor temperature, and they give us the different zones. There are sensors all around the house, and they've been working really well. They're actually linked up to the internet, so I can control the temperature in the house from wherever I am. So the other thing you'll see in the house and throughout the house really is that we redid the lighting. We have very efficient lighting in the house. LED bulbs, LED recessed cans. In this room, because we do try to recycle things and reuse things, we actually took and repurposed all this chandelier equipment. We used, these are maple syrup jars from my family's maple syrup farm in Pennsylvania. And we fitted them with light fixtures, put LED bulbs in, and this is now our dining room chandelier. And we put the spots in the recessed cans, put those on my wife's vintage posters that we try to keep around as much as we can. And you'll see similar elements throughout the house where we really try to get the most efficient equipment in the envelope of the building that we possibly could. Hi, well, now you're in the kitchen. And here in the kitchen, as we did throughout the home, we really tried to use sustainable materials, put in the most efficient equipment that we could. We've got all the LED lighting. These cabinets they're new cabinets, but they're made with sustainably harvested eucalyptus from here in California. We put in the most efficient appliances that we could. We have not replaced the gas stove yet. This is a typical Thermador 6-burner gas stove, but we do have, at least as we're making the transition, we do have an induction cooktop. It was actually fairly easy to acquire. You can get them even at big hardware stores. It just plugs right in and sits on the counter and doesn't use any gas at all. Runs right off of our solar, and is our transition to a fully electrified kitchen. So we actually redid the bathroom here as part of the remodel. We made sure that we put all California compliant, efficient water faucets and the shower head. We've got, of course, the LED lighting. The LED lighting is actually, it's quite elegant. You can get a lot of different varieties. That's nice. And the faucets, of course, you can't tell them apart from any old faucet, but they work really well. We did have to, because we were doing the HVAC redo, we had to run an extra duct upstairs to make sure we got all cool air up there, because the hot air would rise easily just through the existing ducts. We had to put an extra duct in, and we used a little bit of space here in the bathroom for that. All right, so here's one of the cooler parts of the electrification project. We took out our old gas water heater and put in a heat pump, an electric heat pump water heater. This is a pretty big one. We have a lot of guests, so we need to have a lot of hot water sometimes. And we built these closets to fit this heat pump water heater. It is an 80-gallon water heater. It would typically take up a lot less room, but this has a heat pump unit on top and a well-insulated tank that keeps water hot for a long time. A heat pump pulls heat from the air up in our attic into the heat pump. The heat exchanger puts the hot air or warmed air into the hot water, and it blows cold air out. Typically, if you put this in a garage or a small room, it will actually lower the temperature of that room. Here in this closet, we just pump the cold air out into a shed, which keeps some of my supplies, my paint and stored maple syrup and things like that from getting too hot. It actually keeps that shed almost like a walk-in cooler. We already had laundry, but as part of the remodel, we just made sure we got more efficient washer and dryer. These are both front loader units. We had converted from a gas dryer to an electric dryer, and it works really well. We of course try to line dry as much as possible, but for quick items or some heavier items, we might use this. All right, so here we are at the home energy system. This is my power plant, if you will, or at least the control system for the power plant. We started, as I said, by putting solar on the house. This was quite a while ago, right when we moved into the house. We put solar on. They tied that in to our meters here, and that powered our house, but of course, without storage, when the power goes out, you can't even access that solar. So we added storage as part of the remodel. All the equipment, the control equipment for the solar panels and for the battery are mounted here right next to our utility box. What we did in this house, because I put 2 Tesla Powerwalls on, which is a little bit excessive, but also probably warranted here in California, we have the entire house electrical system backed up here. That's why this box is so big. Typically, for a battery system attached to solar, you'd have a smaller box with just a few critical circuits on here. So there might be 3 or 4 or 6 circuits on here. I have every circuit in the house in this electrical panel backed up off of our 2 Tesla Powerwalls. So the solar, I have SunPower panels, I have Tesla Powerwall, they work seamlessly together. That's not a problem at all. Solar not only powers all of the lighting and equipment and everything in the house, it also helps us charge our electric vehicles. We also electrified our transit as much as we could. I actually have 2 chargers available to me here at the house. This is just wired into the normal electrical system of the house. It's a typical charging cord. I run it out to the car, or if the car's parked in here, we plug it into the car. It's a level 1 charger. It takes a few hours to get a decent charge on, but it works great. I also have over on the side of the garage a level 2 charger. This is an AeroVironment level 2 home charger, and that'll get me a pretty fast charge. I can probably get about 50 to 60% of my battery capacity off of that in under an hour. It takes a little more for the last 10%, a little more for the first 10%. But if you're in the middle, if you're just topping up, you have a quick trip to make, Walnut Creek or San Jose or trip down to Monterey, charge up on that real quick and you're good to go. All of this is tied in, as I said, to the 2 Tesla Powerwalls, which are mounted inside of our garage. All right, so as part of moving into the house, we made sure that all the plants in our planters were either local plants and certainly low water plants. We put in a drip irrigation system, which we only turn on in the dry season. We also have, pretty hard to see, but we have some low voltage lights here in the garden as walkway lights. They run off of a little inverter. They're drawing very little power, but they provide nice warm light at night. Make sure that the corner is lit up for pedestrians. And we use very little water for most of this garden here, and still get to harvest our lemons and our citrus. All right, so one more cool feature of the house. We had, as I said, 2 gas furnaces for the 2 original units. We took them out, combined them into 1 heat pump. This is the external unit. So this is the compressor, which does the heat exchange. It can either be hot or cold. And there's an air handler under the house in the crawl space that then blows the air that we want into the rooms. All right, well, thanks for walking through the house and the project that I've been working on all this time. I mentioned that I work in the solar industry, and I want to just leave you with a few thoughts about my decision, our decision, our family decision to go solar and to do all of this work, all this greening of our house. One of the things that you may have seen is, besides the solar on our roofs, is the solar on some of our neighbors' roofs. Solar tends to come in waves. Neighbors influence neighbors to go that way. They show them that it can work. And then those neighbors go solar, and then other neighbors go solar, and friends and family go solar. And that's really important, because the more people that have at least some solar on their roof or in their neighborhood, the more we're doing to balance the grid, to make the grid more resilient, to make it more reliable, to reduce the cost of service. All of us need electricity. The modern lifestyle is powered by electrons flowing through wires. Those electrons can be generated by gas, by coal, by nuclear, by other sources. But those are dirty sources. They're expensive sources. They have impacts on our communities, on our air, on our water, on our soil. Solar, whether it's here on my roof or in a big utility plant somewhere, doesn't have those impacts. When there are outages, when there are brownouts, when there are shutoffs to some of the transmission lines because of stress on the system, these local rooftop systems can help support the energy, the voltage, the frequency. They can be a safe harbor if there is a full outage. We can keep medicine cold. We can provide running water. We can provide all sorts of services. We can charge people's cars from this house if there's an outage. All sorts of services that might be needed in an emergency. And when it's what we call blue sky operation, that is when the grid is operating normally, we are also helping to reduce the peak. We know that this portfolio that you see in this house, that is solar, the storage, the energy efficiency, the electrification of the vehicles, the electrification of all of the services in the house. We know that this portfolio of resources is a really important part of getting our state, our town, our entire Bay Area, the whole country, to a more sustainable footing, to a more flexible footing, so that our energy system can respond to all of the stresses that are going to come from climate change, that are going to come from increased scarcity of fossil resources. And one last thing that I'll leave you with: all of the luxuries that we have in this house, all of the solar and the battery, they are luxuries, but they really do need to be accessible to everybody. And by my family pitching in, and by other families pitching in and buying solar and buying this equipment, we drive the cost down to make them accessible to everybody who needs them.
All right, thank you so much, Sach. Are you here? You need to unmute yourself.
I'm gonna need to unmute. We'll do that. I am here. I am
Thank
here. Good to see you, Amy.
Good to see you too. Thanks for making time for this. I know that you are not here. You are in Colorado.
I am virtually there, but yes, I'm here visiting family, seeing my sister and my nieces and nephews for the first time in a year and a half. So didn't want to put that up.
That's great. No, it's definitely time to emerge from COVID and start to see our long lost family members. So I want to start off asking you about your groovy light fixture in your dining room. And you used a local company, Metro Lighting. And so what was that process like? Did you come with your syrup jars from your family's maple syrup farm and say, help me do something with these?
Yes, essentially that's exactly what we did. And I have to say, it was great working with the Metro Lighting folks. There are a number of options, of course, but we liked their aesthetic. We liked their reuse of old materials and their fixtures. And we had this idea of somehow using these maple syrup jars. As it turns out, if you eat a lot of maple syrup, which we do because it's in our family, you get a lot of jars. So we had all these jars sitting around, and I kept thinking about what I could do with them. Went down to Metro Lighting. They worked with us, gave us some sketch designs, and it was actually relatively simple. They literally, once they built the chandelier and they ran the wires down into a fixture, we just ran it through the lids to these syrup jars and attached the syrup jars to that. So we had to get a good selection of lightly used and abused syrup jars, and they came and installed the chandelier, and it's great. It's dimmable. It provides nice smooth lighting. It's been fantastic.
Yeah, even though this tour is really focused on electrification, I just really like to highlight the ways in which people are doing reuse, and that was just kind of a particularly beautiful way to do reuse. And also a local vendor, Metro Lighting, and I liked that you highlighted, your LED lighting as well, because I think that a lot of us kind of forget that real basic thing of like, use LED lighting. And also, if you go to Metro, I think you can see the different kinds of bulbs, because some people still think LEDs are these ugly white, retina frying bulbs. But I think that when you go there, you can pick out what kind of lovely retro looking LEDs you want in a fixture.
Absolutely. I mean, if the last time you looked at LED bulbs was 4 or 5, 6 years ago when they really first started hitting the market, it's time for another look, because the warmth, the temperature of the light is there's an incredible array of temperatures you can pick. There's brightnesses you can pick. There's a big selection of fixtures that are available. It really has matured as a technology.
Indeed.
That chandelier, when you set it at sort of a dim dinner setting, it's like having candles. It's just like having candles over the dining room table. And it works so well with solar and, and a battery because it's using very little electricity. That entire chandelier fixture uses about as much as a single 100-watt bulb.
Wow.
When it's on full power.
Nice, nice. So Rebecca, what kind of questions are we getting for Sach out of the Q&A?
Sure. Hey, Sach.
Hi.
Good to see you, Colorado. Lots of folks really inspired and appreciated, your comments at the end about making this accessible to everyone. A couple of questions I'd like to combine about your power walls. So the two-parter. So the first is just talking about your decision to purchase your power walls. They're wondering, folks are wondering, they've just gotten solar. Is it worthwhile investment? We know they're expensive. And then related to that, is there an advantage to installing them inside the house, inside the garage, versus outside?
Well, I had always wanted to put battery storage on. I worked as a regulator for a while, and solar is great, but it's a variable resource. And I know that we want to move the energy from the sun from the middle of the day when it's most plentiful to the evenings in particular, when we need it the most. So I already knew that I wanted to do that. As it turns out, over the last few years, batteries have been getting cheaper. There are more offerings on the market. But when I put this system in, Tesla was still the market leader. Sonnen and some of the other brands out there were not really fully available. There wasn't as easy a sales pitch. Powerwall was the way to go. It's a proven technology. The interface is very good. And quite frankly, at that moment, this is about 5 years ago, they were available. It wasn't that long ago for the batteries, actually. But they were available and they work. They work great. I think there are many other alternatives on the market now. SunPower, the solar panels that I put on, they have their own branded storage system. Sunrun uses a different system. That's a very reliable integrated system. So there are a lot of options. I will say one thing about my decision to go with an expensive power wall. I bought the maximum amount of storage that I could use on a residential house. It's because I knew what I wanted. I knew what I was going for. I knew that I was going to have 2 electric vehicles. I drive my son to soccer a lot. So I actually drive more than I would like, even though I'm in this lovely walkable neighborhood. So I knew that I would need a fair amount of power. And we had just been experiencing those PSPS events. These public safety power shutoffs were causing a lot of concern. And I knew that no one else in my neighborhood had yet installed batteries. We were thinking about refuge spots, places to keep medicine, things like that. So I wanted to be able to stand up when the grid went down. So I went with 2 batteries. A typical house with some solar does not need to install that much battery power. You can go for a much lower rate, and many, especially low-income families in California, qualify for rebates. And there's a federal tax incentive that is likely to be extended at this point. So you can actually get a battery, a Powerwall, a Tesla Powerwall, or a Sonnen, or a SunPower, or any of the other options out there for a reasonable amount. What you have to remember with solar panels and with storage is that what you're doing is you're buying all of your energy ahead. So it seems like a lot of money, and it is a lot of money. You have to have cash or financing, but really what you're saving is all the money that you would have spent over 10 to 20 years on electricity. So when you start to pencil it out that way, it kind of makes sense. It is a little bit of a luxury, but that's fine. As far as the question of whether you install inside or out, I chose to go inside because I had space in the garage. There is no reason. These batteries are all weather resistant. They're designed for extremes of weather, much hotter and much colder than it gets here in the Bay Area. So there's not a problem putting them outside. Putting them inside just reduces all that stress factor. It's inside the garage. There's no sun on it. It doesn't have any overheating problems. And it just happened to be the easy choice. But I think it's not something that should cause anyone any stress. Anywhere where it's available, where it's aesthetically able to integrate into your building is probably going to be fine here in the Bay Area.
That's really helpful, Sach. Since you're in the solar field, and you mentioned, there is financing available, there are incentives if you are income qualified. I do have 2 questions. So one is a resource. So for folks who live in Alameda County, East Bay Community Energy is running a program now called Resilient Home with Sunrun, kind of a bulk discount program on solar and storage. I'll drop that in a link when we're done chatting. But as Sach said, there are many companies and providers that you can go through. But can you also, I know that you could lease solar panels or do other arrangements where you didn't have to front the money. Is that also possible to do with if you want to get the backup battery and you don't have the money to front it and you don't want to finance it?
I believe that both Sunrun and SunPower offer such a thing. I don't know if Tesla directly does. I would imagine that they do. The leasing option and the PPA option is a widely in use financial tool in the industry, and especially if you're pairing that battery system with a solar system, financing is available. You can go a zero down low interest loan, or you can go a lease. I went with purchase. By the way, I saw in the chat someone quoting a Tesla Powerwall is about 10,000 a unit installed. That is true, but it doesn't multiply. If you do 2 units, the install costs don't go up significantly. And also, when I bought it, the total install was only about 7,500. It was a little bit less. Just it's gone up. There's a lot of demand for these things. So, sorry, I got distracted by that question. We were talking about the leasing programs. I think leasing is a great way to go, especially for anyone who's facing any cash flow problems or any issues like that. There are ways to attach. You could conceivably attach these investments to your house, to the assessment on your house. That's a little bit more complicated. It's also available. But I think what EBCE is doing is actually really a great program, because they're doing it to help customers to avoid bills and energy burdens, but they're also doing it to improve their resource adequacy and their ability to provide service to the whole Bay Area, well, to Alameda County anyway.
Yeah, I like that. I like that EBCE is sort of it's a different way of thinking about a power plant. It's a lot of people that think of a power plant as a single large plant, maybe out in the desert, instead of distributed, where everybody's home is collectively is the power plant.
Thanks. Yeah. I just dropped the link into the chat. I'll just do it again for folks, since the chat is moving fast. And Sach, if you are able to, I know you're visiting. There are questions in the Q&A and the chat, both of them for you. So if you have time,
I will try to work through those as we go here.
I also want to encourage people to sign up to get emails from Vote Solar to stay abreast of policy issues that can help or hurt solar customers. So thank you again, Sach. I really appreciate you letting us look into your house, and hopefully I'll see you soon.
I hope so too. Amy, great to see you. Rebecca, thank you both. Great to see everyone. And by the way, I'm really jealous of that span panel from
I bet you are.
That was not quite available yet when we did a lot of this install.
Yeah.
Fantastic addition.
Yeah. So our very last house is the house owned by our beloved Rebecca Milliken, and her electrification journey started with terrible indoor air quality. She discovered with really bad air quality readings indoors from her gas appliances, and her path led her all the way to getting her gas plumbing removed at the street level by PG&E, which is a process called decommissioning. I just wanted to let you guys know that there's a UC Berkeley project called EcoBlock, which involves decommissioning gas lines from almost a whole city block in Oakland. And anyway, that's just a little factoid of something that's really cool that's going on in the East Bay right now. So we're going to go to Rebecca's video.
I'm Rebecca Milliken, and welcome everyone. Some of you may actually recognize my name. In my work hat, I do sustainability outreach for the city of Berkeley, and I send out a lot of emails. But today I am taking off my work hat, and I am just here as a neighbor, as a Bay Area resident who's really passionate about sustainability and about electrification. So thank you for coming. Let me just quickly tell you about the house. So I live here with my husband, Isaac, and my 2 teenage sons. And Isaac and I moved here in, oh gosh, it's going to be about 19 years ago. So the house is a typical El Cerrito ranch house. It's from 1948. It's 1,100 square feet. And if you went up and down our block, you would find others just like it. And we were drawn to it because this was what we could afford at the time. But when I came here, I found out that I really loved El Cerrito. We're really lucky that it has a beautiful hillside area up behind the house that we can go hiking, and our 2 BART stations that we can walk and bike to. And it's just a super laid back and warm community. So we've really grown to love El Cerrito. So let me take you inside and show you around. So my electrification story actually started in my kitchen. I knew what I needed to do, but didn't have the money to do it. And so I just started out, the very first thing I got was my electric tea kettle. Whoops. So I didn't have to run one on my gas stove. And soon after, I got my Instapot. I actually just finished cooking something, but I love this because I can put it on early in the morning. And then I stop cooking before 3 p.m. when the electricity rates get high, and just heat it up later. So there's our flavored rice for tonight. So for our family, electrification was about not only reducing greenhouse gases, but really about health and safety. So let me tell you what was going on in the kitchen, which looks a little complicated right now with all these wires. We had a gas water heater right here in this closet, and it was from the 1990s. And that gas water heater, we were keeping it alive that our air quality is really bad. And because of the ventilation, we don't really know how well that was working. The HVAC company said to me, you should keep your kitchen window open all the time when you're cooking and run your fan in the bathroom. So that was okay when cooking, but the water heater, we had no control over that. So that's what I did. And that was all fine and dandy until the fall of 2018 in November, when the horrible campfire started up in Paradise. And at that time, air quality in the Bay Area was really poor, and we were told to stay indoors with windows closed. So there was no way that I was going to be running my stinky gas stove with closed windows. So I turned off the gas, and a friend of mine, a neighbor, Howdy Gowdy, some of you may know him, he's do-gooder all over El Cerrito. He loaned me these 2 portable hobs, that they call them, induction hobs. And since 2018, we've been using those and this toaster oven. So, no making big trays of brownies in the oven anymore. So that was our setup. The gas stove was here, basically holding these up. And we just last week, we did get in a plug that I can show you later, an induction, a plug 240 outlet to accommodate induction range, which we hope is coming soon. I want to show you something that I'm really excited about. So this is where our gas water heater used to live, okay? And it got replaced by our heat pump water heater. It was right in here, and I'm going to even show you, we still have the hot and cold water pipes and the old gas line as well. Right now I'm using it to hang my grocery bags. But now I'm so excited, for the first time in my life, I have a pantry. We used to keep all this stuff in the garage. So I mentioned that we replaced our gas water heater with this heat pump water heater. And this thing is amazing. I love it. And so, for so many reasons. First of all, because I don't hear that gas go sipping on, and I know spewing out pollutants. So what it is spewing out is this nice, or it should be spewing, it's putting out this really nice cold air, and all the warm air is going in here to heat the water. And you may hear some humming in the background. So when it's operating, it does make some noise. And typically these are in basements or garages like ours. They can also be put outdoors. So this happens to go back up against our bedroom wall. And we discovered it was kind of noisy at night. So it's all Wi-Fi enabled. We've programmed it to shut off at 3 p.m. when energy rates go up. And then we keep it off all night. And at 7 a.m. it turns on again. And we have not run out of water for the 4 of us. And this is with teenagers taking long showers. But there's another neat feature too, is we actually boost the temperature high. And I do that between 12 and 3 when I know there's a lot of solar clean energy on the grid. So I boost it up and then we shut it down. And if we knew that there was going to be a planned outage, like a public safety power shutoff, we get warning, we can boost that temperature up beforehand. Then the power goes out and we will still have hot water. I don't know for how long. Hasn't happened yet, but I know that this can at least go from 3 p.m. until the morning without a problem. So part of our electrification was also getting rid of our gas dryer, which was actually our last appliance to go. So just a couple of weeks ago, we sold it on Craigslist for $50, and we just got an Energy Star electric resistance one. We really considered the heat pump dryers, and I know that there are $300 rebates for them now, but there's only one model that's large capacity, and we wanted it to be the same size as our washer, which is still functioning. So we're going to keep this till it goes. But actually, most of the time, we hang our laundry outside. So this is really just the backup in the winter or for when it's raining. So part of why we really fell in love with the house too is because we're on this double lot, and for this area, we've got a really big yard. Theoretically, I'd be a gardener, but I'm thinking maybe in my retirement that will be my next profession. But for now, I get to be out here with the birds and the bees while I hang my laundry. So before we even began electrifying the house, we wanted to electrify our transportation. And even though we bike commute and use BART, for the weekends, we want to get rid of our gas car. So this is a 2017 Leaf. It only has a 100-mile range. Cars today, all the new cars are over 200, some are over 300-mile range. But we do something just called trickle charging. So we don't have a fancy charger. This came with the car, all EVs and plug-in hybrids. And it's just plugged into our outlet over there. And the car has a timer. So we set it to charge the car when electricity rates are low. And PG&E gives us a discounted rate if you have an EV. So I mentioned that around the campfire time, we shut off our gas stove, but we also had to stop using our gas furnace at about that time. One cold day, I went and turned on our heater, and there was ductwork, pieces of ductwork blowing up out of the vents. And we realized that rats had gotten into our ducts in our crawl space and had made their home and chewed them up. Our furnace worked, but as part of the electrification, we were going to redo the ducts and put an air source heat pump. So the neat thing about the system we did, which is a ducted split system, is we were able to use the same floor vents. We don't have to change them. So just like our former gas furnace, which is in the crawl space underneath, we now, have our vents just where they were before. So we have our vents here, and we have our two vents in the living room and in each of our bedrooms. If your ductwork is in good shape, you don't even need to replace it. In our case, since it had been compromised by rats, we first had to get a company in to clean it out and seal up all the holes. And now we have the nicest, cleanest crawl space ever with no rats. And Larry Waters and his team actually put in new ductwork that was properly sized. So that was, and we got a rebate to do that as well. We got, I think, about $800 back to do that part of the job. So this is our Fujitsu 18,000 BTU air source heat pump. This is the outdoor unit. And as I said, I cranked it up to high fan, high heat. And I don't think you can hear it over the car going down the street, but I'll be quiet for a second. But you can see that the plants are moving. It's a little bit because it's windy today, but that's also, I put one right here. That's just the cool air is being pushed out and the warm air is going in. So the other thing I'm really excited about is that this not only provides heat, but it also provides air conditioning. Now you might say here in El Cerrito with the fog belt, I know it's cold today, but with climate change, we have had some really hot, uncomfortable weather, and our house is really well insulated. So once it gets warm day after day, it doesn't cool down. So just for fun on one of these warm days this spring, we turned it on to see if it was working, and sure enough, it is. It's great. So I wanted to show you this place because this is where our gas line right here used to be, and it went through here, and this was the gas meter on the other side, and that was the old vent. And I say used to be because PG&E came and totally, it's called decommissioning our gas line. So they capped it in the street on the other side where it hits the main, and then they literally cut it and took the meter out.
Anyway.
So you can see these yellow lines. This is the gas main, or sorry, the lateral that goes to the main, which is across the street, running over there. And so it was capped. Working for city, I know that policy change is needed at the federal level and international cooperation and collaboration. But cities play a role in setting examples and can start trends that take off, like the natural gas bans in new construction. Berkeley was one of the first in 2019, and now 44 cities have adopted building codes to reduce their reliance on gas, and that list keeps growing. But back to me. I think that individuals, we also have a role to play too. And I've done what I can over the years. It's been small things like reusing plastic bags or hanging my laundry, to getting out of my car, riding my bike, getting an EV, etc. And electrifying my house was the next step. And as you know, it was not just for the greenhouse gas reductions, but also because of our family's health and the comfort of our home.
All right, thank you so much, Rebecca. Hey, everybody, I'm sorry about that tech fail where I muted myself briefly. And so, Rebecca, could you fill in the blank that I accidentally stopped the audio on for a second?
Sure. And Amy, I'm sorry, I think I may have just unpinned you. We'll have Peng in the background work that out. So basically what was happening in the video at that time, I was telling you, I think I was telling you that our gas water heater was from the 1990s. I had been there when we moved in, and we had an HVAC company come and do some air testing. We were really holding that thing together. We were draining it every few years and just hoping it wasn't going to die. And when the HVAC company did air testing, they found that every time we ran our gas water heater or our gas stove that we were getting spikes in indoor air pollution. So I knew that. And that was the part where I then said in the video, they basically said to me, keep your window open all the time when you're cooking, because we have a lousy microwave fan. So it really, I don't know, it makes a lot of noise. I can't tell you what it does. So I could do that, you know, when we were cooking, and we kept our bathroom fan to dry it out. But that gas water heater would, you know, sip on at all times. And then when the fires came and they said, shut your windows, I had that gas water heater going and no way to get that bad air out.
Great. Sorry that I muted it. That's very important piece of your story, which is just the bad air quality and all of the kind of moves that you did to protect your family after having that realization. One thing that I wanted to ask you is, you know, my friend Ellen from the part 1 of the Green Home Tour, you know, she's now completely electrified and gotten rid of all of her gas appliances. And so now she's asking, like, how do I reach PG&E? Who do I call to have them decommission it at the street level so that she can get her meter removed so she doesn't have to pay for the service anymore, just the basic service. And so tell me how you figured out how to get PG&E to come get rid of it.
Sure. Well, once again, I need to do a shout out to Howdy Gowdy. Someone gave him a shout out in the chat, but Howdy has really been a resource for me all these years. And Howdy had gotten his gas meter removed, but not his line decommissioned. And I want to tell people it is free. It cost me nothing. That giant, and forgive me, I think it was a backhoe loader excavator. They didn't use that. That was just there on the job site, got hauled around with them. Oh. So basically they dug a hole at where the gas main was and where our gas, the lateral from our house connects. It was in, and they dug a hole, the welder came, capped the gas line there, and then capped it at our house. So the overall process wasn't that hard. Now, getting started, people have said to me, I don't know how to, you know, I've had trouble with PG&E. So basically, my husband just called customer service, but I did pull up the link, and he said, we want to take out our gas meter. What do we do? And then he got connected with it's called the Building and Renovations Department. And they will send a link, and you fill out an online application describing your process. And ours was a 2-part. We wanted to remove our gas meter. And one thing that didn't come up in all this is that we wanted to add some more electric appliances, and our panel was full. We were able to get our heat pump water heater and our furnace on that same panel, but we did want to upgrade to a 200 service amp. And our panel is located it has to be more, it's either 3 or 5 feet, excuse me, I don't remember which one. They have to be away from each other, and ours was too close, so it wasn't legal to do it. So we were told by electricians, well, you can move your panel, you could relocate it to a new part of the house, and that's going to cost you an additional, you know, $1,000. They said, this is silly. We don't want the gas. Let's just get it out. Then we could just upgrade the panel in the same spot. So we were reaching out to PG&E on 2 folds. One was to do that, and then the other was about dropping a new service line to upgrade that panel. But I'll drop that into the link. You reach out to them. They have you fill out an online application. You will get connected to someone. They might ask you to send a few pictures of your gas meter. And then a field rep came out. He was great. Once he showed up, things got the ball rolling. It does take a number of weeks. And then they scheduled it. But what I do want to let folks know is that if you are no longer using gas, it is important to let PG&E know. You pay a nominal connection fee, like a minimal fee each month that you will no longer be charged. But it's good information to let them know about how many customers are trying to go all electric.
Great. So because it's 1:02 now, I want to go ahead and shift over to the panel. And Rebecca, I just want to, because I'm not going to take questions from the Q&A for you right now, I just want to encourage people in the Q&A, if you have questions for Rebecca, to put it in the Google form link, and then I will, you know, get all those questions to you and she can email you back. And I'm just going to do a screen share briefly as an introduction to the panel discussion, because I realized that I didn't do that earlier. All right, I just wanted to put this up for a minute to tell you who's going to be on the expert Q&A right now that we're going to run for a while. And you saw both Amy and Joseph today as our expert presenters, and you also saw Wei Tai's awesome house in Lafayette. And we also have Kate Ledger joining us. Kate was the architect who designed the ADU that we featured last Sunday. So welcome, you guys, and I'll stop my screen share so that you can be put on screen. I see Wei Tai.
Hi, everybody. Great presentations all the way around. Learned so much.
Hello, Amy. I see you there. And I think we're going to have Joseph joining us again. And the last one will be Kate. Kate, it looks like your video isn't on. Are you just audio?
Is this Kate? I'm unable to access my screen for some reason. Zoom isn't allowing me to access my screen.
Okay, well, I like thinking of you as a little cat curled up in a pot. So Rebecca and I are going to ask you guys questions out of Q&A. So Rebecca, do you want to pull one from the Q&A?
Sure. I was just busy trying to pin everyone. Kate, we'll try to get your video going in the background. So, you know, this was one, actually, Joe, this came up for you. Chris Hunter, who works at Stop Waste in Alameda County and is the Alameda County's BayREN rep, put a note in that the rebates were changing. And I dropped this onto a little, hold on, let me find my notes here. Had said that the rebates were going to be changing and that the existing requirement that you had to replace heating and cooling has been lifted for a ductless system. But someone wanted to say, oh, great, I just did that. Can I apply for a rebate retroactively?
Right. So, I mean, it depends. We do have a little bit of flexibility there. The rebates aren't necessarily, I mean, the process isn't really designed for retroactive rebates, but if the project was installed, at least, you know, if the project completed in 2021, then we could probably, you know, have the conversation and talk about the specifics around the project to see if there is a pathway for rebate, because we have done that in the past, but there are a few variables at play. Like, you know, we would need to ensure that the contractor that installed the work was a participating contractor. If they weren't a participating contractor, you know, we could then enroll them into the program or attempt to enroll them into the program to, you know, to try to get the rebate, you know, for that project. But there is some flexibility there. So I would encourage you to reach out to the advising service, and they'll have information there, and then they will check with myself and contractor services, and you know, we could see if there's it is possible, but often difficult, but we've done it before.
Thanks, Joe. Just a quick follow-up, and I'll let Amy do the next one. Again, related to the BayREN rebate. So one, these are two parts. Is Solano County part of BayREN? And then we have another participant from Santa Cruz, so outside BayREN's area, wanting to know how do they access incentives in, I know that the RENs are regional, so if you could speak to that as well, if you don't live in the 9 Bay Area counties.
Right. Yeah. So Solano is one of the 9 counties in the Bay Area. So if you live in Solano, in a single family residence, and you receive either gas or electric service from PG&E, then you would be eligible. Counties that are outside of the BayREN Home Plus territory, which would be the Bay Area, would not be able to access those particular rebates. But there are Santa Cruz, I'm not sure specifically It's usually the utility in the area will have information regarding the rebates that they have available, usually on their website. Like some areas, like in Alameda County, have municipal service, and the rebate structure sort of is a little bit different, depending on where you're receiving your service, if it's from electric or from PG&E or a municipality.
So I have a question.
Amy?
Yeah.
Oh, sorry. This is Amy Dryden. I just wanted to add on one additional note on incentives, if that's okay for folks. And apologies, Joseph, if you covered it, because I had to step away for family as well during this. But there's a couple of rebate programs that are coming out that are statewide. So there's a lot of activity in this space to like complement and be able to layer with programs like BayREN Home Plus or other things. So just as a heads up, there's a program called Tech that's going to be statewide. That's for retrofitting low carbon space heating and water heating. That should be out midsummer. And then in addition, for new construction, there will be build. So for thinking about new construction, build will be for low carbon new construction as well. And then there's also the SGIP self-generation investment program that used to be just for batteries and PV, that is now counting heat pump water heaters as a thermal battery, because it's installed with that mixing valve that I mentioned, and that Rebecca, you did mention in terms of like your set point of your water heater. So that will also help cover heat pump water heaters, and that is statewide as well, in addition to anything that may be covered that Joseph mentioned through a REN or a CCA. Like in the Central Coast area, we'll see 3CE as a new CCA that's rolling out programs as well. Just wanted to add that.
Okay. So I have a question that showed up from Peter Schultz-Allen. Hi, Peter. And this is actually for Amy Dryden, although others may have an answer to this as well. And that is, Peter is interested in a solar hot water heating on the roof. And so, Amy, could you address that? Because, a few years ago, that was something that had a lot of interest. And so people are still interested in solar hot water heating on the roof. But, the landscapes has changed a little bit. And so does that still make sense?
Good question. And I'll start off, and then anyone else jump in, add or correct or modify anything I say. So I think you can look at kind of solar for a potential like preheat, like that has been done in the past. I will say there's a couple of things for consideration. One, heat pump water heaters like a greater temperature differential for just kind of overall efficiency. So that preheating watt can reduce some runtime, can reduce some overall efficiency. So there's definitely some varying opinions on that kind of operation. I think the other thing that we've seen a lot more on the projects that we've been working on, both kind of single family and multifamily side, is we have limited roof space. And so if I have limited roof space, what happens sometimes is solar thermal can be competing with PV, and potentially, like in the case of Tom, he wanted to put the outdoor unit on the roof because of setback constraints. And so you have a number of things that want that roof space. And so in my experience is that if you can, the more PV panels you can put on there can offset a larger amount of that electric load if you're going all electric. And if you do need some space for an outdoor unit, given your lot constraints or building configuration, you kind of have that piece. So solar thermal is viable. It also has more moving parts. And so over these years, we've seen, I would say, it's just higher maintenance, right? Because I have pumps, I'm moving water or glycol, from my roof to my water heater. And so there's more moving parts, which is increased maintenance and kind of can affect some durability. So on the whole, I'd say like PV's a really great option to kind of maximize your roof space and offset as much as possible. But I would pass it off to anyone else who wants to add or bring some experience to that comment.
I would add, and some experience to that comment, and that is as an architect working with clients, that we've done that because of the dramatic decrease in cost of PV and the decrease in cost of heat pump water heaters. The economics have changed such that it becomes much more affordable or cost effective to go with PV and the heat pumps. And then you also, as you pointed out, Amy, you have, I mean, it's just one less component you have to keep track of in your maintain over time. So we used to do solar thermal and PV, and we switched a few years ago to just doing PV and heat pump hot water heater because that was the most cost effective and the simplest thing to do.
Great, thank you.
Thanks. This is a question that probably all of you could chime in on a little bit, but there's been questions sort of like, what do I do first? How do I stage this? And I know, and many of our chat ambassadors who are from electrification work and have said, reach out to BayREN. And I know I did myself as well. And I got almost $2,000 in rebates. So for me, I know it was because I really wanted to deal with that water heater. I could live with my electric resistance, portable heaters. They were sucking up electricity, but that gas water heater, like my family was breathing that in. So for me, it was like, that was priority. But for someone who's maybe not in that crisis situation that I was with a 1990s gas water heater in their kitchen pantry, should they, if they want to get solar, they want to insulate, I know BayREN will say energy efficiency first. How should they start? It is kind of hard to figure out that sequencing. So I'm thinking, why take Kate, Amy, Joseph, all of you could probably chime in on that.
Yeah, Waite, why don't you take a crack at that?
Sure. I strongly recommend that people interested in doing something with their homes, if they don't want to do the whole shebang like I did, start off with your hot water heater replacement. And there are a couple reasons for that. Number one is that most hot water heaters last for between 10 or 20 years, and you have to replace it, your gas hot water heater, right? So if it's say 1 out of 10 years, that means 1 out of every 10 of you on this call are probably need to get your water heater done soon. And you don't want to wait until it starts leaking and then you're urgently needing to replace it within a day, right? It takes a little bit more time to do a heat pump hot water replacement. So you have to plan ahead. And I'd say anybody who has a hot water heater older than 10 years should start thinking about transitioning out. And the cost to do that is typically around $4,500 to $5,000, but with the $2,000 rebate from BayREN authorized contractors on the East Bay. San Mateo County has like a $2,500 rebate. That gets you basically halfway there. So you can cut your $5,000 down to like $2,000 to $3,000, which is probably comparable to a gas replacement. So it's like the most painless way of doing it right now. And everybody's got to do it within 10 years anyways. And the final thing I'd say is that from a climate impact, that the two biggest greenhouse gas appliances in your house are your heating and cooling, the HVAC, and your water heater. So if you can get rid of one of those, you'd be helping the planet a lot. And so, yeah, that's an easy one.
Great. I see a question from Carol. There's occasional frost in the winter in the Berkeley Hills. Will the outdoor heat pump unit be damaged or can it be insulated? Amy, you want to take that?
Sure. I would say these heat pumps are rated for below freezing temperatures. I think I had like a photo in one of my slides of like snow on top. We've seen them in really cold climates with like little roofs just to prevent the snow from falling on them. They will not be damaged by it. They have defrost cycles, so it's not an issue. We have evolving technologies for really cold climate heat pump technologies, so it's not an issue.
Yeah, I think that heat pumps have had a reputation as only working in certain climates, and I think that people need to know that those barriers are now gone, as far as I know.
Yeah, I actually moved here very recently from Boston, and I could attest to heat pumps are very widespread out there. And yeah, about 10 years ago, if if the temperatures dropped below freezing, the efficiency would drop with it. But the technology's come a long way, and they're able to maintain that high efficiency to even below 0 degrees, which we'll probably won't see out here in the Bay Area anytime soon. So.
Amy, can I make one comment just in terms of the what to do first, and I'll keep it short so you can get to other questions.
Yeah.
I completely agree with what's said already. I would just say, do an evaluation. If you want to go all electric and you want to go all the way, do an evaluation to understand, like, what does that mean today? Because then you can understand what those electrical infrastructure needs may be. We've seen in cases where if we improve the efficiency and make the envelope higher performing, insulate, reduce leakage, we can reduce the size of the heat pump needed to serve it, which can affect what's needed for the electrical panel upgrades. And it also means, like, if I'm planning today, I understand that trajectory. And if I have to upgrade my panel today, I do it with that in mind, so I don't incur additional capital costs in the future when I take on appliance number 3 in 3 years or something like that. So plan today, plan ahead, and then do it over time.
Yeah, it helps to have a roadmap. Yeah, just that. So I see another one that I wanted to ask Wei Tai. Someone asks, do you need solar before you get a heat pump?
And the answer is you do not have to, because assuming we have electricity, we can get the electricity from the grid. We can even opt up our energy from the grid to request 100% renewable energy, so that we would know that our heat pump is being run by clean energy. It just turns out that if you are able to put solar on your own roof, you would be saving money, right? Because the solar on your roof may end up costing something like 10 cents a kilowatt hour, when buying energy from the grid might be 20 or 30 cents a kilowatt hour.
I'll just pipe in, Amy. So in my house, we are getting solar, but it's after the fact, after we've electrified. And we actually don't have that much roof space. So we had insulated years ago. We had a leaky cold house, and we went through the predecessor of the BayREN Home Plus program. So we now, have a well-insulated house. It can be done. And I also didn't need, our electricity usage has gone up very little because we have a well-insulated house and the ducts were sized properly by our BayREN contractor. So it is definitely important to use someone who knows and familiar with it. This is a question any one of you can answer also, but I think it's helpful to explain. We're getting questions. People are wondering about electric tankless. Does it exist, and why aren't they efficient? And if you could break that down in layperson terms.
I can take a shot but I would defer to others, but I'm happy to take a shot. So the question is, I've heard of, oh, wow, how great is tankless? And most of those are gas, like taking a shower and having the tankless go on. I was wondering whether it'd be different. And when I was doing, I did not find products that were tankless electric, simply because the volume of water needing to go through and be brought up to the temperature to keep me warm was just not cost effective. The place that it is cost effective is if you have like a half bath very far away at the far end of your house. And so rather than running pipe and hot water all the way down to there, you can get a small hand washing sink thing, which that tankless electric is, there are products for that, for remote hand washing, but not for showering, bathing, that type of thing. It's still better to use a tanked storage heat pump solution.
Yeah, I'll just add on to that, Wei Tai, because that's right. The electric tankless are all resistant, right? And so if you think about what you've heard from a number of folks today of like a heat pump water heater is compressor, as well as some of them have kind of complementary electric resistance. And so the energy use is significantly larger for a tankless water heater. And as mentioned, it doesn't have a tank. It may have a small, maybe like a 1 gallon little storage. So it's using an incredible amount of energy to heat that. From a code compliance standpoint, not to go into the weeds of codes, but our baseline, now that we have an all electric baseline, is a standard federal efficient heat pump water heater. And the energy use of that is significantly less than an electric resistance tankless. And so from an energy consumption standpoint, it's gonna be impossible to kind of make that comply. But to Wei-Tai's point, the point of use heat pump, or sorry, the point of use like electric resistance water heaters can be really useful in those additions, those farther areas where they're used for kind of a short-term usage, where you want to minimize long pipe runs, or it's really challenging to do that run to that new addition or that like bathroom or something like that off the end. But really heat pump water heaters with efficiencies of 300% more than a tankless is where we want to be going. And they also have tank storage, so in an earthquake, you have a water supply.
We had one quick question for Kate, which is, are you taking new clients?
Yes, sure. Yeah, please give me a call or send me an email and I'd be happy to talk to you about your project.
So what is the typical life of a heat pump water heater? And also there's a question about hybrids where you get the heat pump, like what Tom had had in his house, where he has a heat pump, but then it's a hybrid where they have a little resistance heater, just so when the rest of his family comes to visit, that it just has that extra oomph to it. So yeah, can anybody answer like a typical lifespan of a heat pump water heater?
Yeah, I could speak to it a little bit. I saw them really first starting to hit the market when I got into the industry around 2011. And I have not seen a lot of them being replaced. So I know the warranty on them is typically about 6 years, but they're expected to last as long, if not longer, than a traditional gas water heater would last. Most of them are like a hybrid unit that do have an electric resistance backup component. But if the installer is knowledgeable, there's ways to really, and that backup component is for, when the temperature drops below its setting within a certain threshold, like if it's dialed to 125 degrees and it drops to 120, maybe that first 5 degrees, the electric resistance kicks in. But you can install things like a thermostatic mixing valve, which allows you to dial up the temperature of the tank to something that's 130, 140 degrees. That way, it's not really in danger of falling too low. And then what the thermostatic mixing valve does is it mixes the hot water and the cold water at the faucet to dial the temperature down, so you're not getting hot water at the faucet. So yeah, a knowledgeable installer would really be able to help you avoid those those situations where the water heater is going to kick in and use that high voltage resistance component.
I'll add one item onto that. All of these different hybrids have different modes, right? Whether it's Rheem or whether it's A.O. Smith or Ruud, they have their, they'll have heat pump only. They'll have hybrid, which is a combination of compressor and electric resistance use. And then they'll have high demand. And I think Tom had mentioned the high demand. And most of them have, if they are hybrid, they have 2 different resistance elements in it, maybe one at the bottom, one at the top. Those modes are proprietary manufactured logic. And so it's a little bit hard to understand exactly when things are getting tripped. So what I would suggest is operating your heat pump water heater in heat pump only mode is the best way to go. That mode is the only mode that really minimizes the electric resistance use. The hybrid uses the electric resistance quite a bit. Even though they call it the eco kind of most cost-effective mode, I would say it's not. We have seen that is not always the case. We see electric resistance coming on a lot more than we anticipated from some of the monitoring we've been doing. We monitored over 22 heat pump water heaters. And then the high demand obviously is going to have a lot of electric resistance, and that's when you have, maybe everybody over, you're getting a lot of draws, large draws, and you don't want to draw the tank down too much. So be conscious of those modes and think about how to operate them. And yeah, I would say the lifespan is like 15 years, which is probably, our gas water heaters are 10 years, but we always keep them for like 18 anyway. So, it's a pretty good lifespan. And there are some newer heat pump water heaters that are coming on that are compressor only. As I was mentioning, these kind of retrofit ready are compressor only, 115 volt, 20 amp. And then like the Sandin, that's part of the Harvest Thermal system that we saw earlier. The Sandin is a compressor only system as well.
So this is one that I'd actually like to hear from a few different people on this. Who or what organization can help with a roadmap of what to do when getting rid of gas? So in some ways, like the point of this Green Home Tour altogether is to start giving you a roadmap, but also showing you that everybody had a different map. Like everybody, went through these upgrades in a different order from each other, depending on a lot of different factors. But so I will hand it over to Kate first. Like Kate, when you were working with a client, how do you help them determine what their path is going to be?
Well, I guess for me, what happens is, with the people that I'm working with, they've already generally thought about their desire to electrify their building, and they're doing it as part of a bigger project. So the electrification is generally a smaller component of an overall big remodel, and it's actually tends to be a smaller budget, piece of the big picture. Remodels are, you're doing an addition or gutting and redoing your bathroom, and you're reconfiguring the floor space. So they've already made the decision they're going to electrify, and then they work with us to incorporate it into the overall project. So I'm actually not sure I'm the best person to answer that question. So maybe someone else has a better answer about how to create a roadmap. Because for me, everyone's they've already decided they're doing it, and they do the whole thing at once.
Yeah. So Wei Tai, how did you go about creating your roadmap for what you were going to do and in what order?
I just dived in. I didn't know what I was doing, right? So I learned a lot along the way. I learned a bunch from my contractor, Eco Performance, out in Concord. I actually just put a link in the chat. I wrote an extensive blog about my experiences and posted on the Sustainable Lafayette website. So I gave you the link to the first of 5 entries that sort of step-by-step explain my thinking, my strategy, why I did it this way, what rebates there were or there were not in my case. And so maybe just reading that experience could be helpful to folks. But yeah, there are not a whole lot of expertise 2 years ago, but because of workshops like we're having today, there's just so much more coming to the floor. It's just like a snowball getting ramped up. So I think there's a lot more online and a lot more people like the ones on the call today that are helpful.
Yeah, Joseph, you wanna, I mean, obviously, I point people to BayREN and energy advisors as like a good starting point to find people to work with to make that pathway for your own individual home and circumstances.
Yeah, absolutely. The advising service is a great resource to utilize if you're just starting out, or you're like, I'm ready to embark on a project. I don't know where to start. Our advisors are a good resource to kind of start with. Also, like Wei Tai, like you mentioned, our contractors are super informative. We Eco Performance Builders, they're awesome. We have several contractors that are home performance focused. So our advisors always encourage homeowners to, contact as many contractors as you can, have them come out to the house, give you a quote, talk about, their approach to it. And then once you have like 2 or 3 or 4 or even 5, different proposals, you could sort of weigh then you have all the information, to make the decision, yourself as to, what's going to work best for your situation. So we always encourage, reaching out to those contractors, having them come out, and then at this, connecting with our advising service throughout the process, not just one phone call, but, reach out to them initially. And then once you have the proposals or the estimates, if you'd like to go over those in detail, our advisors are there. They'll take a look at them. They'll share out, their experiences or their their concerns, even with the estimates. So we're here to help sort of provide that guidance throughout the whole process. So yeah, we'd encourage you to reach out to our advisors and contractors, and yeah, and then that kind of gives you a good information base to make a decision.
If I could tag on to Joe's comment that BayREN has been really a center for all of the rebates and training of contractors. At the same time, in just the 2 years since I've done this one, it seemed like there was nothing available. And now there are a lot of incentives and workshops that there's a rush to those very limited number of contractors. So somebody just put in the chat, Marilyn, thank you for saying that there's actually a long backlog. If you do call one of the contractors, they tend to be, may take many months to get to you. And so that is sort of a frustration, but it's also like a good problem to have. It just means there's a lot more interest in this area. There's a lot more money available. So hopefully the contractors at BayREN will continue to expand the pool and training, right, for new contractors to do it. But just to set expectations, there are a lot of people doing this right now.
Yeah. And two of the biggest names that I always recommend are Larry Waters and Electrify My Home and Eco Performance Builders are two that companies that are out in front and very trustworthy and know about electrification. And of course, for those and Harvest Thermal is once they get out of beta testing, I'm sure that a lot of you guys are going to be interested in that all-in-one system as well. Yeah. So we should probably wrap it up since it's 1:34, and thank you guys for being part of this panel. I really appreciate all your expertise. I'm sure that you all keep having questions, so I want to remind you guys again that the Google form link in the chat function is a place where you can ask pointed questions and get it to these specific experts or other ones that you've seen as part of this tour. So I'm going to say goodbye to you guys, and I'm going to hit screen share to go back to a final couple of slides. So I really want to thank everyone for attending today. I want to thank Kathy Kramer for planting the seed for this event in the first place. I want to thank the partners and sponsors who contributed to this endeavor, including the Margulies Kelly Climate Action and Health Fund. If you found this event valuable and want to see programming like this in the future, I hope that you'll consider donating at eastbaygreenhome.com, and Rebecca will drop the link in at the chat. Donations of any size to support this programming are enormously appreciated. And I really hope to run this tour again next year and to show you even more green features. And if you are out there as an attendee who has done a lot to your home, please nominate your own home for next year's tour. If you have green features that you think we should highlight and you'd love to tell other people about, and you can reach out to me through the event website, eastbaygreenhome.com. Thanks again for attending, and I hope all of you have a great summer. I just saw a lot of Q&A, people in Q&A asking about recordings, and I want to reassure you that both last Sunday and this Sunday's event were recorded, and we will make the recordings available. And I really hope that you share them with your friends and family that you want to turn on to some of these features and concepts. I'll be reaching out to you, everyone who signed up and registered at Eventbrite. I'll be sending you an email once those recordings are available, and hopefully it'll be within the week. All right, thank you so much and have a great summer.